I've spent quite a bit of my professional career trying to get on board the JavaScript train. It's a fantastic language, but for some reason, I just can't quite get to grips with it for a lot of reasons, probably mostly my fault. But where does that leave somebody like me, a C# developer that wants to write single page applications, interactive web applications, running on the browser? What am I to do? Is there anywhere for me to go? Well, if you stick around, maybe there is a solution. Well, hello, wherever you are, whenever you are. Where am I? Melbourne, Australia as usual. And when is it? It's May 2021. So that was, yes, a very cheesy introduction to what we're going to be talking about today, and that is Blazor. And what is Blazor? Well, it's a lot of things to a lot of people, but in my mind, it's Microsoft's attempt at a kind of single page web application framework without the need to use JavaScript. And that sounds interesting. Well, you're in the right place. And in today's video, more specifically, what we're going to be doing fully step by step is building a Blazor client, a Blazor application that's going to call a number of APIs out on the internet. One REST API, one GraphQL API, and the way we're going to architect our application is that we can swap those implementations out nice and easily without having to do too much additional work. And you'll also see how you can write applications like that without actually using any JavaScript at all. So hopefully that sounds interesting. It's another long video, it's about 3 hours long, so buckle in, settle in, and let's get started. So yes, welcome to this full step-by-step course on building a Blazor API client using both REST and GraphQL API endpoints. Quite a mouthful, I'm sure you'll agree. Now, before we do anything else, let's take a look at what you're going to be building if you decide to follow along with the course, which I really hope you do. So over in our project, I'm just going to run it up, .NET run, and you'll see we get a little Kestrel web server running on local host 5001 and 5000. So if we hit one of those endpoints, I'll just start Edge, and we'll get our Blazor client. Here we go. Now, we get some stuff out the box with this project. We get a home page or a home component. We get a counter component, which just allows you to increment the counter, not particularly exciting. And we also get this fetch data component, but just stick a pin in that for a moment. The first thing we're going to do as part of our build is build our own component that allows us to convert to and from base64. So this is a string, encode it as base64, take that out and decode it. Now you might go, what has that got to do with APIs? Doesn't really seem to have anything to do with APIs. It doesn't really. The reason we're doing this is to get used to building components. So you'll understand how they're architected, how they're put together, different approaches to building components, that sort of thing. So it gets our feet wet before we jump into calling APIs. So that's the first thing we're going to do. The second thing we're going to do is revisit this fetch data component. Now this is a component you get out the box with this project template. And out the box, what it does is it reads in some JSON data from a file, just a static file. It's got weather data in it, and it displays it on screen. But what we're going to do is retrofit it to make a REST API call. And if we click on it now, it actually goes out and makes a REST API call, pulling back some data. Don't worry, I will talk about what the APIs are and what the data is a bit later, but you can probably see on screen what type of data we're getting back. So that's the second thing we're going to do. We're actually going to make an API call using one of the existing components. And then finally, the third thing we're going to do is create a totally new component. And on the surface, it's going to look like it's doing exactly the same thing as our fetch data component. But behind the scenes, it's doing a whole lot more. The way we architect it is much more sophisticated. So what you're actually seeing on screen, it looks exactly the same. And in fact, it's pretty much doing exactly the same thing. It's going to a REST API and it's pulling that data back. But I did mention we're going to be working with both REST and GraphQL. So the way we're going to architect our application is that we can swap out our implementation of REST really quickly for an implementation of GraphQL. So I will jump into the code at this point, close down our little server, And you can see here we're going to be working with something called data services. So we have a REST implementation, which I won't go through, and we have a GraphQL implementation, again, which I won't go through. But what I will show you is in our program class, we can easily swap out one data service for the other. And the way we do that here is simply by registering the implementation class with our dependency injection container. So we were using the REST data service. All we need to do is use the GraphQL data service, and that is it. Save that off. We'll run it up again. We'll refresh our client. Now we'll get exactly the same data back. It will look no different, but we are calling two different APIs that use different design patterns. One is REST, one is GraphQL. We'll cover both fully step by step. Now, if you don't know what dependency injection containers are or anything like that, don't worry, we cover it all in this course. So that's running up now. Let's come back to our client and we'll just do a refresh just to show you I'm not full of hot air, although I am full of hot air. Come back home, we'll refresh and we'll come back to launches. And now it's going to a GraphQL API, which actually looks a bit quicker than the REST one. I'm sure for no other reason than it just happens to be a bit quicker, and you can see we get back exactly the same data, but using this different implementation class. Fantastic. So if you come with me now, you're going to learn how to build this, and I hope you very much do. But the next thing we want to do is go through the course overview in a bit more detail so you know what you're going to be doing at each phase. So let's do that next. So let's just come back over to PowerPoint. We'll go through the course overview. Now, just before I do that though, I just wanted to say, if you want to skip ahead to a particular section, and I'll go through the sections in a second, and you want to just jump to the API development part, you can do that. All the time codes are in the description below. So if you want to just jump there, you can do that. You don't have to watch bits maybe that you're not too interested in if you want. But I would recommend, obviously, that you watch the whole video. Up to you though, you can do either. So let's take a look at the course overview. So introduction, we've already done the demo. I'm going through the overview now. After this, we'll go through the solution architecture of the solution you're going to build, and then the ingredients and tooling. We'll then spend some time on Blazor theory. What is Blazor? Why you would use it? And the flavors of Blazor. There's two flavors of Blazor. And then we'll talk a little bit about WebAssembly. We'll then move on to coding, and we'll do a full project setup. So we're not downloading stuff from GitHub that's already got loads of code in it. We're doing it completely from scratch. So .NET new project all the way up. So project setup, we'll go through the anatomy of a Blazor project. So if you've not done any Blazor stuff before, there's a couple of nuances when compared to some other .NET stuff. So we'll go through that anatomy and we'll build our first component, which is that base 64 encoding component. Coding part 2, we'll take a look at the APIs we're going to be using in a bit more detail. We'll make some test calls with a API client called Insomnia. We'll then use HTTP client to retrofit our fetch data component to pull data back from one of those APIs. And then we'll go on to a discussion about something called HTTP client factory. And we'll talk about splitting concerns within our components, and we'll talk a little bit about app settings. Now, if some or all of that made absolutely no sense to you, don't worry, I do explain it all fully when we get there. Coding part 3 is really the main part of the course, and this is where we are going to build our second component to call both our REST and GraphQL APIs using data services that implement those specific design patterns. Okay, so that's really the main part of the course, although it just looks like a small section, that's the main part of our course. And then finally, we'll move on to the end of the video, where we'll talk about next steps, bit of wrap up, and then support our credits. But I think now we move on to solution architecture. Okay, so let's take a quick look at our solution architecture. Now this is the architecture that we are going to be building to, obviously. And we'll start with looking at the fact that we have two APIs, a REST API and a GraphQL API endpoint. Now these are externally hosted. We do not build these as part of this video. It would just take too long, and it's not really the focus of today's video. Now I've selected two APIs in particular. I'll talk about them later when we come to that. You can of course use your own APIs if you want to do that, but to follow along I would suggest you use the APIs that I've selected for us, but you can of course use any ones that you like. Next you'll have your local machine, you'll have your web browser, and this is possibly a little bit too much detail at this point in time, but within your web browser is this thing called WebAssembly, or you might hear it called WASM or WASM, I'm not sure how you pronounce it. It's not a plugin, it's nothing like that, and I do talk about it in more detail later, but it's just something that is required in this particular architecture to run our Blazor app. But don't worry, it's not an install, it's nothing additional that you have to do, it is just there, and it is required in this architecture. We'll also need a web server. Now, as part of our project setup, doing .NET New and setting up our new Blazor app, we're going to get this out the box. And if you've done any .NET programming before, you're probably quite familiar with the Kestrel web server. It's just a little development web server. We need that to basically serve up our application. So we'll visit that server, we'll visit the endpoint, and as a result of that, we will get our Blazor app downloaded onto our browser, into our browser, and it sits on top of this thing called WebAssembly. Don't worry, I cover WebAssembly in a lot more detail later. And from there, the app will then talk to our APIs, make the relevant calls, which is really what we're going to be doing as part of this build, and pulling data back into our app, and everything will look wonderful, I'm sure. Now, just on this architecture, if we then stop the server, the app will continue to work. It will work in this offline mode, and it will continue to work fine. All the server in this configuration is really doing, it's just acting as the delivery mechanism of our application. That's all it's doing. Unless, of course, you decide to put something on that server like an API, it's not required unless you do something like that. So we can stop the server, the client will continue to work. If, of course, we went to refresh and download a new copy, then we would run into results, obviously. But that's it for the solution architecture. We will revisit this a bit later when we talk about Blazor in more detail, but for now, we can move on. All right, so let's take a look at the ingredients you'll need if you want to follow along. So VS Code text editor, I recommend that one, it's free. You can use anything you like, including Visual Studio if you want to do that. But again, this is a VS Code based tutorial. You'll need version 5 of the .NET Framework. I'm not going to show you how to install that, just Google .NET Framework, download and follow the instructions. It's pretty straightforward, so I don't feel I need to take you through that in this video. I recommend either Insomnia or Postman. Now, they are just API test clients. They are not mandatory, but they're useful when you are writing code, your own code to call APIs, and you can use them to test the same APIs and see if you're getting the same kind of results or not. They are useful. I'm going to use Insomnia as part of this tutorial. And then around about 2 hours of your time. I've not actually timed it yet, so I think it should come in hopefully under the 2-hour mark if you want to follow along with it. All right, so we're moving on to a bit of theory now, and we're going to talk about what is Blazor along with some other questions. And I've tried to balance this section with providing enough detail so that it's, number one, it's interesting, and number two, that it gives you enough background so when we go into the coding part, you kind of have a bit of an understanding of what is going on. But at the same time, I didn't want to go into too much detail, so hopefully I've got the balance correct, but you can let me know whether I have or not. So before we move into that, let's just talk about most web applications today. Now, when I talk about, in the context of this video, talking about a web application, I'm talking about web applications that are running on the client in your browser. So effectively, don't like saying this, but effectively JavaScript-based applications, okay? That's what I'm talking about. Now, you will, I'm sure, appreciate that you do get other patterns of web app development where the code is executed on the server and then HTML and CSS are then rendered down to the browser. We're not really talking about those type of applications today. We're really focused on the ones that, sit on the browser and are predominantly JavaScript based. So as you can see on screen there, most web apps today are comprised of HTML, of course, of CSS, which is used for styling, as I'm sure you're aware, and then JavaScript. Now, even frameworks like React and jQuery and Angular and all those kind of things, they fundamentally use these technologies. There are some nuances and some differences, but effectively, everything is based on these three things. Now, if you're wanting to write interactive web apps, basically, you need to know JavaScript. Okay, there's really not much, no other way around it, really. In the past, going back, there were things like ActiveX and even things like Silverlight and what's the other one, Flash and stuff like that. But basically, these days, JavaScript is really the main way that you would develop an interactive web app or a variant thereof of JavaScript. Now, the real question is, what if you can't use JavaScript? Or when I say can't, you don't want to learn it, or you don't have enough time to learn it, or something like that. What do? You're a bit stuck today. If you want to build an interactive web-based app, you're a bit stuck, really. So this is where Blazor really comes in. So what is Blazor? Well, free, good, open source web framework from Microsoft. And so really, in a nutshell, what it allows you to do, it allows you to develop client-side apps written in C#. So you don't need to use JavaScript, you can use C# as the language of choice to drive these interactive web apps. Really importantly, no plugins are required. So I did mention things like ActiveX and Silverlight and Flash and all that kind of stuff. You don't need any plugins. Everything you need, by and large, will reside in your existing browser that you are running and watching this tutorial on today. And as I've said there, everything that the World Wide Web Consortium recommend is all you really need to use. So basically, all modern browsers will support this framework effectively. Blazor apps can still interact or interop with JavaScript, so you can actually use JavaScript functions or call JavaScript functions from within your .NET methods, which we're not going to cover today, but it's a very cool feature. And yes, Blazor comes in 2 flavors, and we'll cover these in a lot more detail in the coming sections. So Blazor Server and Blazor Client, or Blazor WebAssembly. Now, an important point to note here, and I keep labouring this point, these are 2 separate flavors of Blazor. They're not part of the... You don't use both at the same time. So typically when you see something like client server, I immediately go to the kind of space where I'm thinking there's a client and a server and they work together. That is not what this is. You either use Blazor server pattern or you use the Blazor client or the Blazor WebAssembly pattern, one or the other. So does that mean that JavaScript is dead? Of course not. Absolutely not. Positively no on that one. Blazor really, in my view, is an alternative to JavaScript, and it's an alternative in some fairly specific use cases, and I actually fall into one of those use cases, as I'm sure you may do if you're watching this. But yes, it's not a replacement for JavaScript, and I don't think it ever will be, to be honest with you. Microsoft may have a different view on that. I don't think it will be. And in fact, as you'll find out in a bit, it's actually somewhat dependent on JavaScript as well. You don't need to learn this JavaScript, but it's somewhat dependent on it all hanging together and working. So why would you use Blazor? What is the use case around it? Well, I've kind of covered it already, but basically the main primary use case is when you want to use C# as opposed to JavaScript to develop web apps. And the reason for that is that you can, like myself, leverage your existing C# skills. I know JavaScript a little bit, but I struggle with it. I don't really have time or the inclination to learn it. If I had all the time in the world, I probably would, but I just don't. So for me, I'd rather just use my existing language skills to build those web apps. And as I said earlier, I don't have time to learn something else like JavaScript. And another one, I mean, I do this quite frequently. I would use Blazor to quickly prototype apps, prove a concept, and then once the concept has been proven out, another team may take over and actually then redevelop it using something like React or something like that. So it's maybe, for me, it's a quick way for someone like myself to create apps, web apps, very quickly that may not eventually make their way fully into production, and someone else may take it and build a React version of the same app. But yeah, these are the kind of things I'm thinking of anyway, but predominantly it's for people who want to use C# to build web apps. All right, so let's take a look at the 2 flavors of Blazor. And again, I keep mentioning this, but you would use one or the other, you don't need both to be working at the same time. So Blazor server apps are actually hosted on a server. They're hosted on an ASP.NET server. They run as an application on the server. And the client, the web client, is really nothing more than a presentation layer. It's a thin client. So if you're very old like me, you may remember green screen terminals that are just a presentation layer. They're not very smart. They just talk to a back end, a mainframe. Or if you're not that old, you maybe use, even today, things like Citrix or Remote Desktop, where you just have a client that is effectively just presenting a desktop from some other server or application somewhere. And that's really the kind of model that Blazor Server is following. The apps run on the server. And the way the client, the web app, and the server interact with each other is using something called SignalR. And again, I've got a slide on that in a second, which is basically another Microsoft technology, fundamentally based on WebSockets. And again, we'll go into more detail about what that is in a second. But basically, this connection is persistent, and the client just sends, basically just update messages to the server, and vice versa. The server just sends messages back to the client that tells it how to render the user interface effectively. So really only the client document object model is updated, and the document object model is effectively just the structure of the web page. And so all the server is doing is telling the client to augment and change the DOM so that the user interface changes in response to things like button clicks and searches and all that kind of stuff. So yes, the client is presentation only, and because it's relatively simple from a browser perspective, although it does need to support WebSockets, it basically works on all browsers. There's probably very few browsers where this setup would not work. So Blazor client apps are quite different, and this is the pattern that we are going to follow in this tutorial. We are going to follow the Blazor client approach. So as you already saw in the solution architecture section, the app code is downloaded in full from a server, and it runs on top of WebAssembly, which is this component in all modern browsers. And again, we'll talk more about WebAssembly in a bit. The server can in fact be anything. So Blazor server needs to be an ASP.NET server because the app is actually running on that server. In this instance, the server can be anything. It doesn't have to have .NET installed or anything like that. It just has to have the packages there, the DLLs there, that can be pulled down and hosted and run in the client, which is quite good actually. It can work offline, as you've seen already, so the server can then kind of fall away and the app will continue to work. That would not be the case with Blazor server. You need to have this internet connection or this network connection for Blazor server to work. And yeah, as it said, it will run on WebAssembly. Now, I did a bit of checking. Most desktop browsers, about 93% of them at the current time, have WebAssembly capability. So it's pretty decent coverage, and I'm wondering where the other 7% are. They're probably Internet Explorer running in corporations somewhere that can't or won't update because they've got some legacy intranet application that needs Internet Explorer to run some ActiveX application. I would imagine that's probably the case. But for the most part, yes, WebAssembly is available on most browsers. Now, a really important point to note is that you can develop a Blazor app and it theoretically can run in either hosting configuration. You shouldn't really have to change anything. Now, there are a couple of caveats around that statement, and I'll talk a bit about them later in the video, but you don't have to write an application for the server setup and then fundamentally rewrite it for the client setup. The same app should run in either configuration, so that is also a huge bonus. And interestingly, when Microsoft first brought this out, Blazor server was the original flavor that they brought out, and then when WebAssembly gained more traction, they kind of brought out this other alternative way of using Blazor. So a bit more of a deeper dive into Blazor server. You have a server obviously that is running or needs to run ASP.NET, and your app will run inside that runtime effectively, and you'll have a separate app running for each client connection, which I've not shown here. You'll then have your local machine with a web browser on it. It will make a HTTP request to the server. There will be a HTTP response with I suppose I'm calling it a thin version of the app. All the app is really doing is running some HTML and a bit of JavaScript to set up this SignalR connection. And so the HTTP session falls away. If SignalR or WebSockets is supported on this connection, then that's what will be used, and it's a fully duplexed, fully persistent connection, and the thin app just talks to the actual app on the server backend. And then if we were calling APIs, the APIs are actually being called from the app that are running on the server. Okay. So a little bit about SignalR. It's an open source library from Microsoft, and bear in mind we are not using this configuration, but I just thought I'd give you a bit of detail on it. I have done a video on, quite a long video, about 3-hour long video on WebSockets and SignalR and why they're different. So check that out if you want more detail. Predominantly used for real-time asynchronous type applications, so where you need a kind of persistent connection and real-time events traversing that connection. Signaler is really quite clever. It uses the best available transport. So I keep talking about WebSockets. WebSockets is one type of transport. If WebSockets is not available or are not available on the connection or on one of the endpoints, then it will use the next best option. So it might use HTTP long polling or something like that. But from a user perspective, using the Signaler libraries, you're completely unaware of that. It takes care of that for you. So it's quite a nice framework. But fundamentally, it aims to work on top of WebSockets. And as I say, it will fall back to other methods if WebSockets are not available. So if using WebSockets, the connection is bidirectional. So it's, fully bidirectional and nailed up. Unlike HTTP, which is a kind of request response stateless kind of protocol, this is a stateful protocol that is persistent. And just a little diagram there. So this is kind of how a WebSocket connection is typically established. There'll be a HTTP upgrade request. And if both endpoints can support WebSockets, then WebSocket connection will be established and will be persisted, and then will obviously be closed at some point based on either client or some other event. But that's it for, I'm not going to cover Blazor server anymore. If you want to read more about that, I'll put some links below, but we are now going to focus fully on the Blazor client architecture or the Blazor WebAssembly architecture, which is what I'm going to show you now. Now, you've actually already seen this in the solution architecture right at the start of the video. So local machine, WebAssembly running in that web browser, any server, doesn't have to be a .NET server or anything like that. The app will be downloaded onto the client, and then the client will make the connections to the APIs, or make the calls to the APIs directly. So let's talk a little bit about WebAssembly now. Now I've updated this diagram that was right at the start of the theory section where we were talking about HTML and CSS and JavaScript. WebAssembly is really this fourth piece of the pie now. And I'll tell you why I believe that to be the case. It's an open standard, which is really specifying this portable binary code format that will actually run on top of WebAssembly. The whole goal of it is to enable highly performant apps on web pages, and I've kind of put on in bold and italics because, again, coming back to this point, the web apps we're talking about here are web apps running in a browser. And the reason I'm saying it's really this fourth piece of the pie is that in December 2019, it was a World Wide Web Consortium recommendation that WebAssembly be adopted as a core technology along with HTML, CSS and JavaScript. So again, want to labour the point, open standard. This is not a Microsoft thing or a Google thing. It is an open standard similar to HTML, JavaScript and CSS. Theoretically supports any language. We are going to be focusing on C#, obviously. This is really important. One of the questions you may have is that, what speed does it run at? JavaScript will presumably run a lot quicker than this. Possibly, very ever so slightly, but it does aim to execute things like C# code at almost the same speed as JavaScript would execute. It runs within the same sandbox environment anyway. And it's available on all four major browsing engines. Well, really three. Edge is effectively, Chrome isn't it these days, but Edge, Chrome, Firefox and Safari. And again, I've mentioned this already, you don't need to enable it, you don't need to download it, it's not a plugin, it is just part of your existing modern browser. And then before we move on to coding, I just want to make the distinction between WebAssembly and Blazor effectively. So you have WebAssembly, Blazor or C# runs on top of WebAssembly. So Blazor allows you to compile C# applications into WebAssembly runtime components, but you may or you do in fact have other languages that can run on top of WebAssembly, such as C#, Rust, Go, and I'm sure there will be many others. But point to take away from this slide is WebAssembly is one thing, Blazor is a separate thing that kind of works with WebAssembly. Blazor client, should I say, is something that works with WebAssembly. The Blazor server doesn't make use of it at all. All right, so that is definitely enough theory. I think now we move on to coding. All right, so let's begin coding. So I'm just going to open a new Visual Studio Code window. That's where we're going to be doing all our coding today. And let me just kill the welcome message. And then I'm going to do control back quote to open the integrated terminal and change into my working directory, which in this case is on my D drive, in my season 4 folder and in my episodes 2 folder. And of course it will be different for you. Now let me just check there's nothing in there. No, there's nothing in there. Great, so clear the screen. Now before we go on, I just want to check to see that I have .NET installed and installed the right version as well. So to do that, it's .NET -- version, and I have version 5 installed. Now if you get an error message there or you see a lower version number than 5, then go away and install the latest version of .NET Framework. Pretty easy, pretty straightforward, so I'll leave you to do that yourself. Fantastic. So let's take a look at the templates that we have available when we want to scaffold up a new project, and we just type .NET New to get that list. And we are wanting a Blazor WebAssembly project. So here we are, Blazor WebAssembly app is the one that we are after. Now that's just the Blazor client that I've been talking about in the previous slides. And you can see above that, you have the Blazor server project as well. But up key, we don't want the Blazor server, we want the Blazor WASM project, and we will give it a name, and we'll call it Blazor API Client. And that will go away, and it will scaffold up a new Blazor WASM project for us. So quick directory listing, we have a folder there, and let's just open that up recursively in our existing Visual Studio Code session. And that should load. Fantastic. Now we may get a message down here saying, do we want to rebuild some assets or something of that nature? We usually get something like that. Interesting if we don't get that. There you go. I'm just waiting for that to pop up. Yeah, so do we want some required assets? Just click yes. And we get this .vs code folder, which we don't need to go into too much more detail with. So I think what we'll do now is we'll run up the application, we'll see what we get, and then I'm going to move back and forward between the application and this project, and we're going to go through the anatomy of the project so you understand what everything is and where it fits into the bigger picture. So let's do that now. Okay, so just before we run the application, what I'm going to do is come into our program class, and for those of you who've done any .NET programming before, you'll appreciate that the program class and the main method specifically within the program class is really where our .NET applications get kicked off. It's really the entry point for the application. So I'm just going to put in here a console write line, and I'm just going to put in Blazor API client has started. Now you don't really need to do this. This is just for me while I explain what's going on with the application and how it starts and where everything happens. This is, yeah, you don't need to do this. You can if you want, obviously. So what we would expect is when the main method gets hit, that message, Blazor API client, will get pushed out to the console. Okay, so just wanted to do that. Just stick a pin in that for the moment though. And what I'm then going to do is open up the integrated terminal again. So control and back quote. And then we'll just do a .NET run to run that up. Fantastic. Now you'll see a few things here, and the fact that our application was built and no errors, that's good. You'll see that we are running on 2 endpoints, or the server that's been started is available on 2 endpoints, one for HTTPS and one for HTTP. And you'll also see that we have our hosting environment set to development. Now, interestingly, you'll note that nowhere in that console output is our little message that we put in there. That's not there. Why? Because we've not actually run our Blazor client app. All we've done is run up a Kestrel server. That's all. That's going to eventually serve our app. So you can see here, .NET run. This is the entirety of the output. That has not been written out yet. Before we go on to that, let's just take a look at where this stuff came from. So if you go into the properties folder and look in launch settings JSON, you will actually see some stuff that looks quite familiar. Our application launch URL with those endpoints in there. Our environment has been set to development. And the only other thing that wasn't appearing in that output, but I will mention because it's somewhat interesting, is this inspect URI. That is required if you want to do interactive debugging, which we're not doing here in today's video. Now this profile got picked up because we're running our application at the .NET command line. If you're running your application in Visual Studio, for example, one of the other profiles would be picked, but we're running in the .NET CLI, so this is the profile that get picked. So we're not going to do anything else with launch settings JSON, so we can close that down and kind of forget about it for now. Our application, well, be very careful here, our server is still running. So let's go over to Edge and see if we can call one of these endpoints and pull down our Blazor client app. So if we come back over here, I'm just going to copy that. You can't click on it to launch a window. I'm just going to copy it. And before I do that, I'm going to open Development Tools by hitting F12. And I'm going to make sure the Network tab is selected, All is selected, and we have the previous output from this last application, which is Bing. So I'm going to paste in our endpoint. Pay attention to this window here, the top left window here, and just see what is going to transpire. So hit enter. You can see loading appear up here, and then our application appears. So we'll cover that in a second, and then you can see all sorts of network activity. And one of the things you can see is as a result of that request, a whole load of Microsoft runtime stuff has been pulled down. And you'll also see when we come a bit further down, you'll see the Blazor API client DLL has been pulled down. Now that's our actual application. Now what I want you to pay attention to is the initiator of these requests, and it's something called blazor.webassembly.js, a JavaScript file. That's been responsible for actually pulling this stuff down so that our application can run, and I'll show you where that is in a second. Now the other thing I want to show you is if we come over to our console, you'll actually see something that looks a little bit familiar. I'm noticing I've put an E at the end of Blazor, it doesn't really matter, but our Blazor client has started, and that message has been pushed out to the web console in our browser, so that makes a bit of sense. Now one thing you'll see here is that it knows it's Blazor, which is cool, and you can see that the resources have been loaded, fantastic, and all the resources have been loaded from the network, okay? This is the first time we've grabbed this application, so you saw that whole host of Microsoft runtime stuff come down. If we refresh, you'll see we still have the same number of resources, but you'll see that the majority of them, if not all of them, have come from the cache. So in this instance, we've not gone and pulled all that other stuff down again. So it's only the first time we do it, it gets cached, and then subsequent loads will be a lot quicker, as you actually saw. Fantastic. So that's our application up and running. I think I'll close this down now. And let's take a quick look at what we've got here. So we've got a navigation pane down the left-hand side. We have a few different buttons. On our home page, we have this Hello World page. Now, before I go on, everything in Blazor, or most things in Blazor, the important stuff in Blazor are really called components. These are the building blocks of any Blazor app. So what you're actually seeing here, this Hello World page is basically a component. In fact, this survey box here is also a component, and it's actually nested inside the Hello World component. Our counter is a component, and if you click on this, the counter will be incremented, so nothing terribly exciting. But what is exciting is that this is not JavaScript that's executing, this is C#, this is executing, okay? And then finally our fetch data component is going and pulling down from somewhere some data. Now I can tell you this data is just coming from a static file, a JSON file that's being read in. Okay, so that's basically our application. It's fairly simple. So what we're going to do is we're going to actually update this component to go out to the internet and pull data down from an API, which it's not doing at the moment. And then we're going to add some other functionality to the application to be a bit more sophisticated. But why don't we pop back over to the code now, and I'll just take you through what has been going on there, if I can find the correct window. There we go. So I might just kill this for the moment, just so we get a bit more space, and close that down. And so what I want to show you is the entry, well, it's not really the entry point, but the initial page that gets loaded is this index HTML page. So when we made a request to our server endpoint, this is the page that gets loaded. And it's a fairly well, straightforward HTML page. It has a head, and it's just pulling in a lot of static styling resources, CSS, as you can see there. And then within the body, there's some interesting stuff. Now, one thing I want to draw your attention to is this loading ... here. You saw that when the page was loading and it was waiting for the application to get loaded. Okay, but once the application has loaded, this is where it actually runs. It runs within this app division here, or this div tag with an ID of app. This is actually where it runs. We then have another div, which is for any errors, and I'm sure we'll have some as we move through the application, so you'll see what that will look like when we generate errors at some point. And then finally, within the index page, you'll see this blazor.webassembly.js file, and that was the initiator of everything getting pulled down. So this script runs, and all our stuff gets pulled down and populated into here, and that's where the application actually runs. Now, you will remember that I did say Blazor was somewhat dependent on JavaScript. This is what I mean. We do need a little bit of JavaScript to get this all up and running. You don't need to write the JavaScript, you don't even need to see what it's doing, but it is dependent on it to some extent. We're staying within www-root. There's a couple of folders in here, one for their CSS resources and one called sample data, which has this static weather JSON file, and this is the file that got read into that fetch data component. So that's all that is. So we can safely ignore that now. The only other thing worth mentioning about www-root, if you wanted to provide an app settings JSON file, which you often get with .NET projects, that is where you would put it in the www-root folder, and it just gets read in and settings are available. Now, we're going to be making use of that later, but for now we can kind of park the www-root folder. So then the other things that I really want to take you through is this pages folder, and you'll see possibly some things that look a bit familiar. Counter.razor should I say, is our counter component, and our components are written as Razor. Okay, and if you've done any ASP Razor Pages stuff, it should be familiar to you. Razor is basically a mix of code, C# code, and HTML, and in this case it's all in the one file. Stick a pin in that for the moment. And one thing you'll notice is that each component has a page directive at the top, which is basically telling the application where you can find that component. So if we actually come back and rerun the application, and we click on counter, you'll see basically this is what it's referring to. It's routing to the counter component. Okay, so kill that. I'll leave it running actually and just close down the terminal. So this is our counter component. Fetch data, pretty much exactly the same, but you can see interestingly that we're getting a HTTP client object injected into this piece of Razor that we are using to retrieve our weather data, and it just writes out to a table. Okay, so you can see sort of HTML mixed with some code, and then actual code block that has, you know, a page load or uninitialized async page load effectively, and then another class here that will actually retrieve the data we use to populate the data. And you can see it's in the one file, so again, stick a pin in that for the moment. Index Razor is basically our hello world page. So again, coming back here, back home, it's this one here. And then interesting, you can see it's making reference to another component called survey prompt. And that moves us nicely on to this shared folder where we have some additional components that are shared amongst the application. So survey prompt is in there, and that's all this is referencing. And then we have our main Razor, that's the CSS page. We have our main layout component, and you can see it's referencing our nav menu component, which is also in our shared folder. And again, that just relates to this section here, and the main is obviously the entire window. Fantastic. Now we're going to be working mainly within the pages folder, well actually exclusively within the pages folder to create new components, but we will be visiting and updating our shared folder, specifically the nav menu, to add some new navigational items to the menu when we come to doing that. Now the only other thing really I want to mention, imports Razor is just a list of using directives, so that's just pulling in the relevant stuff that we need to make reference to, so I won't go into that in much more detail. But the only other thing that's really worth talking about is this root component here. So app.razor is what's called our root component, and what that is really responsible for is routing. So when we select the counter component, for example, this is responsible for routing and displaying the correct component. Okay, Blazor API client .csproj is just a project file, and it's pulling in some package references. I don't think from memory we touch this, but again, those of you familiar with
.NET programming, you'll be familiar with this. And then finally, we come on to the program class and specifically our main method. And this is really the last kind of piece of the puzzle, really. You'll see that, yes, this was written out to the console in the web console window. It's responsible for building our host, which is basically our application. Here is where we're setting up our root component. And you can see here that it's adding it, the app root component, which is this one here. It's adding it to our app tag or app div in our index file. So here, so it's basically loading it into here. Here's the ID app, and here it's referencing it using the hash app convention. We're also using dependency injection. I'll cover dependency injection a bit in this tutorial, but basically what this line is doing is making a HTTP client available to us throughout the rest of our app. And you'll remember, hopefully you remember, if you come back to the fetch data Razor component, that we were actually injecting a HTTP client in here for retrieving our static data. So that's what that's doing there. And then finally, the application is running. So that's basically our sample app. It's scaffolded. That's the main anatomy components of our application. What I'll just finish off with is just showing a bit of a slide that basically just repeats what I've gone through. But I don't know about you, but I find a picture is sometimes a bit better to help me understand what's going on. So the first thing we did was a .NET run. So .NET run, and then that basically just launched our Kestrel server and then pulled in that launch settings JSON file, which I showed you. And then it was just listening on these two endpoints here for activity, but the actual app hadn't run yet. So then the app launch proper was when we made a request to localhost port 5000. That called our index.html file. That then called the Blazor WebAssembly.js, which pulled down our runtime and our compiled DLL, which you saw. And then the program class effectively kicked off and the main method really executed. And what that meant was, well, yes, before we move on to that, you could alternatively, and we will be doing this, is add an app settings JSON file to the www root folder. We've not done that yet and it's not there by default, but you could provide that and that will provide additional settings into the main method. But what that did was it built our main app host. It allowed us to specify where our root component was and where it should go. It registered the HTTP client in our dependency injection container, and then finally it runs our app, which runs in the app tags within our index.html. And then basically that is our app. And we had a look at some of the components that were in there, namely our counter and our fetch data components. And we'll be creating our own components next, which is really the rest of the video. So why don't we get on and do that? So we're going to build our first component, and on screen here you can see a screen mock of what we're actually going to build. And in this case, we're going to build a component that allows us to convert to and from using base64 encoding. And base64 is just, yes, it's just an encoding standard that's used quite frequently throughout different IT applications. So for example, if you've ever used basic authentication, that uses base64 encoding to encode the username and ID when you send that across in the header. So I thought it'd be a good example for us to get started with, to start working with Blazor components. So we will add a button to our navigation pane, point number one, with a nice little icon. We're then going to actually create our new component, and it's going to have a couple of text areas or text boxes, one for the non-base64 encoded string and one for the base64 encoded string. We're going to have a couple of buttons to encode and decode from, and they will have events behind those. And then there's going to be some C# code that's actually going to do the encoding. So covers all our bases, gets our teeth cut on building components, and it sets us up really well to move on to the next part, which is actually building components to consume data via APIs. So let's get started and start building out our user interface. All right, so let's just take down PowerPoint, as much as I hate to do that. You know how much I love PowerPoint. And we're going to come across and we're going to create our first component. So in Pages, right click, new file, and we're going to call it base64 converter.razor. Now, it's important how you name your Razor components because ultimately they get converted to a class effectively. So you really need to make sure the first letter is capitalized on your component names. Now, we're going to put all our markup and all our code into this Razor file. As your components grow more complicated, you will undoubtedly split out your code and your markup just to kind of keep things a bit separate, and we'll do that when we come on to doing the API stuff. But for now, this is a relatively simple component. We're going to keep everything in the one file. So the first thing we're going to provide is a page directive, which you'll remember is used for routing. So we're going to give it the same name as our component, so base64 converter. Fantastic. And then we're going to launch into the markup. So in this first bit, we're just going to do effectively just HTML markup, okay? Now, fair warning, I am not as you're probably aware, a fantastic UI type person, so my UI skills are quite rudimentary. So yes, fairly basic, but functional. And just as another sidebar, as part of the project Scaffold, you get the Bootstrap CSS framework packaged up with that. So we're going to use Bootstrap classes to help style our UI. Bootstrap has some people who love it very much, some people who don't like it so much. It's probably fallen out of flavour in the last few years. I still quite like it. Huge subject area, all of its own. I'll put some resources down below that you might find useful, but it's not something I can delve into, nor do I want to too deeply in this video, so bear with me. Now, there's a bit of typing involved here, but I think it's worth doing, at least for this first component. So the first thing we actually want to create is the first thing we want to create is our heading, isn't it? So h1 tag, and we'll just say base64 converter. Fairly simple. We then want to do one of our text boxes, but we want to put that in a div, and we're going to get, not a dick, in a div, and we're going to give it a Bootstrap class of form group. And this just kind of groups form elements together in one little package, and it just styles it a bit nicer. So we're going to put a couple of things into this form group. And again, form group is a Bootstrap styling class. So want to create a text area. And again, another class is going to be the form control. And make sure you spell form correct, not typing it as from. And then some sizing. And this, to be honest with you, for me is the most confusing part of Bootstrap, how things are sized. And it's all to do with reactive user interfaces and massive topic. Just go with me on this one, that's what we're going to use, but again, do your own research. Placeholder, and this is just the text that will appear sort of by default in our text box or in our text area, so non-base64. And that's it for now. We will add a couple of event handlers in here at one point, next actually, but for now we're just going to keep it as sort of pure HTML and CSS. And then the reason we're using a form group is we're going to add another little small tag, which will give us some small text underneath our text box describing in more detail what it's for. And it's there you go, I've spelt it wrong already, a form text, and then text muted, again, just giving us some styling. And then we'll put the text in. So this is the value you want to encode as base64. Now let me just do a Control B just to clear down that sidebar so we have a bit more room. That's all looking quite good. So that's our first text box with our heading. So I think we probably should run it and take a quick look to make sure we've not done anything massively wrong. .NET run. Okay, and I'll just fire up Edge, and we'll see what that looks like, and hopefully it should look somewhat like our mock-up. So localhost 5000. Let's just go straight to base64 converter. There we go. So yeah, it's not looking too bad. Now obviously we don't have our button here yet, we'll do that later, but we have our first text box, or text area, which we can, resize. And we have our kind of, subtext here and our placeholder text. So it's all looking quite good. It's looking kind of similar to our mock. So that's great. So let's keep going. We're going to add our 2 buttons now, and then we'll add our other text area. So back over here, let's just kill this from running. Let's take this down, and we'll start on our buttons now. So no surprises, it's going to be a single button. Again, we want to style it, so we'll give it a class, and we'll say btn button, obviously, and then we're going to color it as a primary button, which is blue. Okay, and then we're going to give it a type, which is button, and that's it for now. Keep it relatively simple. And then what we want to do is we can just say, you know, encode, and that will obviously provide that wording within the button. But what we can also do is provide a little icon, like the down arrow and the up arrow. So we'll put that inside a span tag, and a span tag is really just there to, yeah, do stuff like put icons on the screen. It's a kind of, I don't like calling it a nothing tag, but it's kind of, this is what it's kind of for. Now what we're going to use actually is we're going to use an icon framework called OpenIconic, and I'll actually just bring that up so you can have a look and see what that's like. Type it in here, it's probably, here we are. Use OpenIconic, yep, and I'll put links to this down below, and you can see here it provides us with a load of icons, and this is actually where these icons come from in the sort of boilerplate application. So yeah, I know what icons we need to use. It's the up and down arrow, so you can actually search for them. So I think if you type in arrow here, you'll get a number of arrows. So we want to use the thick bottom arrow and also the arrow thick top to represent pushing stuff up and down between our text areas. So we're going to do that now. Let me get that down. So yep, it's a span class, and then in the styling, you're going to specify OI for OpenIconic, and then we actually specify the icon that we want. So the first one we want is OI arrow thick bottom. I'm tempted to make a joke there, but that's probably very politically incorrect of me, so I will resist doing that. And yeah, just close the span out, and all that does is put an arrow next to our encode word, and I've put a space in between here. So let's just copy this. I'll save you from typing anymore, and copy that in. This is our other button that's going to push stuff up. So we'll say style it as button success, which will make it green. And then we'll change our icon to OI arrow thick top. Perfect. And then we'll change this to decode, and that will perform our decode operations. And then finally, let's just copy this, and this will be our text area where our actual base64 encoded string will exist. So let's just change the placeholder text, base64, and then we'll change this text here. This is the value you want to encode from base64. Hopefully that makes sense. So we'll save that off. Now that is basically our user interface done using just HTML and a bit of sort of CSS, a bit Bootstrap, and that's it. So we'll run this again, we'll take a look, and then if we're happy with it, we'll move on to actually writing some C# code and putting some events behind these buttons and doing the more interesting stuff. So let's quickly run it up, and we'll take a look and see how it looks. Hopefully it looks wonderful as per our mock. So let's come over here and let's refresh. And they're pretty close. There's a bit of a, you know, the buttons kind of sit directly on top of this other text box here, but you know what? I'm going to leave that for the moment. Now, actually, just before we move on, the only other thing we want to do is create a button here, just before I forget. So let's just kill that again. And it's pretty simple. I'm not going to do a lot of typing here, so we'll come back into our project, and we'll go into our shared folder this time, and you'll remember that we have this nav menu Razor component with all our buttons in it. So I'm just going to copy. You can see here we've got 3 existing buttons effectively. They're just list elements in an unordered list. Try saying that after a few beers, and we'll just paste that in here. We'll keep everything the same, and then we'll just put the route to the component. So base 64 converter, and we'll change the, again you can see here they're making use of a icon from the Open Iconic library, and the one I want to use this time is random, and you'll see why in a minute. And then we just want to change the label, the actual text, to base 64 converter. So hopefully that made sense. The href is just taking us to the component. We're just creating another list item under the other one, so we'll get a fourth button, change the text, and change the icon. Cool, very simple actually. So let's do another .NET run, and hopefully we should see these changes propagate through, and indeed we do. Now because we're actually already on this component, it's highlighted, which is actually really nice. It's highlighted this button for us already. You don't even need to do anything styling wise. So we've now got our base 64 component from a user interface perspective ready now to do some more interesting stuff, which is write C# code executing on the browser. So we'll move on to that now. All right, so let's just minimize this, and we're going to come back to our project. So I'll just kill the running server, get rid of our terminal, and we'll close down nav menu Razor. We don't need that right now. So we're going to be doing most of our work within our base 64 converter component. Bit of a mouthful. So what we want to introduce now are some events into our UI elements, and as well as introduce some C# code that's basically going to run in the browser and perform this conversion to and from base 64. So what we'll start with is looking at our button elements, and this is probably the most familiar part, I would imagine, for most people. It's not unusual to expect that when you click a button, event will be triggered, click event, and then when that click event is triggered, you would usually do something with it, like submit a form or call a method, and that's what we're going to do. We're going to call a method for each button, converting again to and from base 64. So what we're going to do is come back over to our first button, the convert, or the encode button, encoding to base 64 button, and we're going to introduce our on-click event. It's actually really straightforward. So type the @ symbol, gives us our kind of Blazor event list, and we will look for on-click, and there it is there. It's the first one, I think. And then we just make it equal to the method that we want to call. Now these methods don't exist yet, so we will get some errors if we did a build at this stage, but let's just specify the name of the method we want to call. So this is our encode button, so I'm going to call it convert to base 64. And that's it really. Obviously we have to create this method somewhere, but that's it for our event on our button. So we'll just copy this, and we'll do exactly the same thing down here on our other button, our converting from base 64. So we'll just call that convert from base 64. And so yeah, we do still need to write these two methods, which we'll do in a bit. Cool, so that's our buttons taken care of. Very simple. And then the next thing we want to do is probably a little bit more interesting. And before I move on, let me just close down our side panel by doing a Control B. So we're going to add some stuff into both our text areas. And what we really want to do is we want to bind the contents of our text area to a C# property so that we can then work with that C# property. So the way we go about that is introducing this thing called a bind value. And again, this is another bit of Razor code, and we specify a bind value. And what are we binding to? Well, we're binding to, or we want to bind to, an as yet undefined C# property. And I'm just going to bind it to a property called non-base64, and I'm just going to say body, just to kind of distinguish it from some of the other things that are flying around in the code. So basically, we're going to create this property in a bit, and we're going to bind the contents of our text box to that property. And it's a non-base64 encoded string at this point in time. Now you can see it's complaining. And the reason it's complaining is, yeah, fair enough, we're telling it that we want to bind to this as yet undefined property, but how do we do the binding? And the way we do that is by specifying a bind value event. So these two things kind of go hand in hand with each other. So again, we specify bind value. This time we specify the event that creates this binding. And we simply specify the event name. So the event name in this case is not on click, but on input. Not input, input. There we go. on input. So just to recap, every time you type something into the text area, the onInput event will fire and it will then bind or rebind the contents of the text area to our bind value, which in this case is a C# property. Make sense? Cool. Should do. It's not that complicated. So I'm just going to copy this and I'm going to copy it into our other text box, but I will change the name of the bind value in this case. So just paste it in and I'm going to take out the non, because this text box is the base64 body that we're going to convert back to non-base64. So hopefully that makes a little bit of sense. So I will put a link to an article by Microsoft, a bit more about Blazor eventing, and it covers a lot of this stuff in a bit more detail, but this is all we really need to do for our project, so all good. Now I've just noticed I have put this in the wrong place, so let me just take that out, put it in the closing tag. I should have really put it in here. So for those of you who spotted that, well done. I'm glad I spotted it before I tried to run the code. Now, if you do try and run the code or build the code, we're going to get a hell of a load of errors because none of these properties or methods exist yet. So I'm not even going to bother building because I know I'm going to get errors. So we're going to keep moving onwards. So in order to resolve the errors that we haven't yet seen, but I know are there, we need to introduce our methods and our properties. Now, the way we do that is by introducing a code block. So it's just @code, curly brackets, and then we now have a section where we can enter our C# code. Now, when I talked about splitting out concerns and moving code into a separate file, it's really this bit here that you would split into a separate C# file, which we could do now. Not going to though, we will do that later. We're going to keep it in the same file for the moment. So the first thing that I want to do is create our two properties. So prop, tab, the first property is a string, and the first property is this non-base64 body. So I'm just going to copy that out, and I'm going to set that to this here. Fantastic. And then we're going to do our second property, tab, string, and I'm just going to type it in this time, it's base64 body. Okay, and that's basically this bind value here. So something that's already in base64. And again, just to keep repeating the same thing, the value of our text box or text area will get put into these properties automatically on input. Fantastic. And then all that's left for us to do is really to create our two methods that are going to allow us to convert to and from base64. So let's do our first one. Let's do our encoding or converting to. So private void, no. My typing is getting worse as I get older, and we'll just copy the name exactly just so there's no scope for error. There we go. And we're just going to access our properties directly. We're not actually passing anything in via the method. You could change that, I suppose, if you really wanted to, but I don't feel there's a need to do that here. So kind of a two-stage process. The first thing we need to do is create a byte array in order to then convert that byte array to base64. So we'll create a variable and we're going to call it plain text, capitalize the T, bytes. And we're going to make that equal to, we're going to use system text encoding, so encoding to UTF-8. Now we're not getting IntelliSense here, and I'm imagining that's because we don't have this using statement, the using system text anywhere. But let's keep going for the moment, because I want to show you something anyway. So get bytes, and then we want to get the non-base64, actually it's here. So whatever's in the non, assigned to the non-base64 property, we want to take that because we want to convert it to base64, and we're converting it into a byte array effectively. Then this is the clever bit. I think it's quite clever. What we then want to do is make use of this property, which bear in mind is bound to our second text box. And what do we want to do with that? We want to assign that a value, and the value we want to assign it is the converted plain text effectively. So we'll use the convert method on system, and you get a whole host of stuff on this. So we want to make use of to base64 string. Great. And then what do we want to put to a base64 string? Our byte array here. I'll paste that in here. So hopefully that made sense. So we will click our convert to base64 button. We'll call this method. it will take whatever is in the non-base64 property, which is bound to our first text box upstairs, converts it to a byte array, and then we convert it to a base64 string and assign it to our second property, which is bound to our text box below. Fantastic. So this should all work now, but I want to keep going and I want to do our second method. But I'm going to suspect we will get a compile time error because it doesn't know what this is. But let's keep going. We'll do our second method and then we'll tidy that up. We'll resolve that issue in a second. So private void convert from base64. Almost the mirror opposite of what we've already done. So we want to create another variable, and this time I'm going to call it base64 encoded bytes. And we'll use the convert method again, but this time it's from base64 string. And what we're passing in the base64 body. So the property bound to our text box below. There we go. Again, just the opposite really. And then we want to, like we bound to the base64 property, we want to bind to the non-base64 property because we're doing it the other way. Hopefully it makes sense. When you see it working, it'll probably make a lot more sense. And again, we'll make use of encoding, which it's not aware of, but let's keep going. UTF-8, hopefully I typed this in correctly. Get string. And what do we want to convert this thing here? base64 encoded bytes. So I think we're pretty much ready to go, but I suspect there'll be an error, a build error. So let's just do a .NET build. And we have 2 errors. Okay, that's good, yeah, because encoding, we've used it twice. So encoding does not exist in the current context. So there's 2 ways you can resolve this. Well, it's really one way, but it's doing the same thing in 2 different places. So we can just bring in a using statement up here and use system text. If we save this and we do another build, it should resolve our issue. Indeed it does, fantastic. But I'm not going to do that. I'm going to take this out of here. And what I'm going to do, because I kind of skipped over, I didn't skip over it, but I kind of didn't pay much attention to it when we were going through the anatomy section. Down here you have this imports razor file. You can just pop it in here if you feel you're going to be using system text elsewhere in your project. And I feel probably it's a fairly standard thing that we may be using elsewhere when it's certainly when we come to be using our APIs. So I think it makes more sense to put it here at a more global level. So let's save that off and we'll do a build again and we should have no errors. Indeed we don't. So all that's left to do is run this up and hopefully it all works as we would expect. So there we go. So let's refresh our app. So the first thing we want to do is convert to base64. So I'm going to enter in a string. This is not base64. We'll click our encode button. That will call the relevant method and then populate, hopefully, there we go, fantastic, our second text box with the converted value. I'm going to take this out here and I'm going to decode and it goes the other way. So you can decode and encode between base64. So if you've followed along, give yourself a round of applause and a gold star and smiley happy face, well done. Okay, so that's us finished with this component. Well, I'm certainly finished with it. You might not be, and for the following reason. The reason being that we've not really done any proper error handling or anything like that. So I want to show you what will happen. Let's come back over and reload the client. So we have nothing, no values in our text boxes. And if we try and encode what is effectively null, we'll get an error. And there you go. And you'll see the error message pop up here, and this was actually the error div from the index.html file. That's what it looks like. So easy enough to fix. I actually wanted to generate an error and show you what those errors look like, and this is what it will look like in the user interface. And if you actually want to go in and look at the errors, hit F12 to bring up your developer tools. If you're using Edge and Chrome, I think Firefox might even be the same. Go to your console and you'll see the output here, and you can just see, yes, null reference, the very ubiquitous null reference unhandled exception. So we need to make a check for that in our functions to make sure we're not trying to use a null object. Easy enough to do. Not going to do it here. A little bit of homework for you to tidy this up so it's a bit more enterprise ready. Other than that though, we are done, and we're going to move on to the API stuff in the next section. But just before we do that, just to kind of recap what we've done here, we have created our first component. We have routed to it by putting a box on the nav menu so we can get to it that way. We've done our user interface, which is basic but functional. We've added binding and events to some of our user interface, or actually all of our user interface elements. And then we've written some C# code executing on the browser that will actually do our base64 encoding and decoding. So simple, but not so simple, but it's covered. I think it's given us some good coverage to move on to the next section, which is I think what you've been waiting for, which is consuming APIs using Blazor. So what are we waiting for? All right, so let's take a look at, finally, the APIs we are going to be working with throughout the rest of this tutorial. So one REST and one GraphQL. So without further ado, here's the first one. Here's our REST API. And well, actually both APIs are going to be working within the same domain, in this case, SpaceX, the private space agency. But what you're seeing on screen is the Swagger or OpenAPI specification for our first API, the REST API. Now, I don't believe these are actually official SpaceX APIs. I think they've been put up on the internet by some kind person that will allow you and me to work with them, so thank you to you. Not that that makes any difference, but yeah, I just thought I'd call that out. I think they're just someone's passion project. Anyway, back to the point at hand. So yeah, this is the REST API, and you can start to see the types of things that you can do with this API. It's mainly read requests or get requests, and you can pull back things such as the launches that SpaceX are going to be executing or that they've already done, missions, the rockets that they have, all that kind of stuff. You get the rough idea of what this API is going to allow us to do. Okay, and then if we pop over, I'm just going to copy this, take a quick look at the GraphQL API. I actually have to put, there we go, it actually resolves to GraphQL, that's good. Slightly different tool, so again, this is Swagger or OpenAPI, which is a way of specifying or documenting REST-based APIs. And what you're seeing here is something completely different. It's a tool that allows us to query GraphQL endpoints. It's called graphical. I think that's how you pronounce it. And in this case, it just allows us, to actually, let's just do it, query the GraphQL API. And you can see very similar, sort of almost analogous to the resources that we see here. You have what are effectively objects that we can query, okay? And I'm not going to go into too much detail here about the differences between GraphQL and REST. I think we'll do that as we actually start to exercise these APIs. So these are the APIs we're working with. Both relate to exactly the same domain, which is SpaceX, and we're going to be using REST and GraphQL. All right, so what we're going to do next is actually start to exercise them, and we're going to do that using a separate tool that's going to exercise both these APIs. And I think in doing that, you'll start to appreciate the nuances and the differences between them and the similarities, most specifically the data payload that they'll both return. All right, so we're going to do that next. So as I said, I'm going to use a tool called Insomnia to start exercising both our APIs. It's a tool I use all the time. I really like it, and it's particularly good for GraphQL for reasons that you'll see in a moment. Now, if you want to get hold of it, it's free. So just pop over to Google, and I suggest you look for Insomnia. Do Insomnia. I totally spelled that wrong. Insomnia API. And that should take you to the main website. And so it's called insomnia.rest, although it does REST and GraphQL. So just click on this. Free, get started for free. And download the app. And just click on, in this case, I'm running on Windows, download Insomnia for Windows, but you get it for Mac and Ubuntu. So highly recommend it, it's a great tool. So enough of that, and I'm not affiliated with them or anything. I don't make commissions or anything like that on Insomnia. That's free anyway, so I wouldn't. So back over to my instance of Insomnia, and I'll just bring that back up. And you get different workspaces or collections, I think they're called. Request collections. So I'm going to create a new one for this video. Season 4, episode 2. And we'll click create, and that creates a nice empty environment for us. So I'm going to create 2 folders. one for our REST requests, and one for our GraphQL requests. Now, of course, you don't need to do this if you don't want to, but I find if you're calling lots of different APIs on different platforms, and even this, a reason I like this tool as well, is you can create different environments, so like one for staging and test and production. I find it is worth investing in organising your requests right from the start, because I've fallen into this trap where you end up with hundreds of requests, and if you've not organised them well, it can become quite laborious to navigate them. Anyway, let's work with our REST API first, and let's come back over to the Swagger specification. Here we go. And I want to look at launches, the resource. Now, you can probably infer actually from just looking at this here that if we simply append launches to this, that should get all our launches. So why don't we go ahead with that theory? We could drill in here and actually look, but I'm going to make that assumption. I think it's a fairly safe assumption. So over in REST, click the folder, new request. I'm going to call it get all launches. All right, and it's a GET request as per the Swagger spec. Now, just before I click create, with REST, as I'm sure you're appreciative of, you will get GET requests to read data, POST requests, typically creating data, creating resources, put and patch to update resources, and delete to delete resources. Stick a pin in that for the moment. I'm calling that out specifically for a reason. When we come on to GraphQL, it's slightly different. Nonetheless, let's keep going. Get request, get all launches, click create. That then creates a GET request, and in our URL box, I'm just going to paste in the base API URI, and then just type launches, okay? And that should, if you click send, looks like it's working. It's going to take a while. It'll bring back, here we go, all our launches. And this is just a JSON payload with every single attribute for every single launch that SpaceX have. Now, stick a pin in this for now. We're going to go through this in a bit more detail when we come on to coding, but I just wanted to test that this is working, and it looks like it's fine. There's no authentication. I don't think we've got any headers at the moment, which is not best practice, but we'll cover all that a bit later, but it seems to work. And this is one of the reasons why I like these APIs. They're very forgiving. Some APIs, when you call them, you have to make sure that you're providing a user agent header, you're specifying the content type, they may require authentication, and that's good, but for purposes of this video, that can be quite problematic. So these APIs are very forgiving, very easy to call. You shouldn't have many problems with it. So let's just create another request. Let's get all the rockets. So get all rockets, get request, create that, paste in our base URL, and I'm going to guess, I'm not even going to go to the specification, but I bet rockets will bring back all our rockets. And looks like that has worked. 200 response, and we get JSON with all our rocket details. Fantastic. Cool. So you're probably more familiar with REST than GraphQL. That is a bit of an assumption, but on my travels, that tends to be the general lay of the land. GraphQL, people aren't typically as familiar with, so let's have a look at that now. So right-click our GraphQL folder, new request, and we're going to get all launches. Okay. Now, I made a bit of a song and dance about, with REST, you have GET requests to read data and POST requests to create data, blah, blah, blah. With GraphQL, for the most part, any GraphQL query or mutation, and a mutation is basically a GraphQL's way of saying creating data, updating data, deleting data. It's any unsafe operation in the GraphQL world is a mutation. Doesn't matter though, mutation or query, doesn't matter, they're always a POST request. More than usual, more than likely. You can use GET requests, but I've not actually seen that personally ever being used, okay? So GraphQL, always a POST request. Doesn't matter what you're doing. Reading data, creating data, deleting, update, doesn't matter. Always a POST request. I'm not going to ever say that again. And then for the body, you will select GraphQL query and click create. Now straight away, we're kind of getting an error. There's no URI in there. That's okay. So let's come back over to our GraphQL endpoint and let's paste this in and see what happens. Now, again, I can't remember if I mentioned this, but with GraphQL, there's only ever one endpoint. for your particular domain. Okay, so unlike REST, where if you want to get rockets, there's one URI, one endpoint. For launches, there's another URI, another endpoint. With GraphQL, that is the only endpoint you ever put in, and you specify your objects within your query, which we'll do in a second. So our error is gone, which is great. Another thing, which has probably happened automatically, but I'm going to do it manually, is do this refresh schema. And what that's really doing is it's going to the GraphQL endpoint here, and it's pulling down the entire specification for that API, and it's loading it into this tool. And what does that mean? Why is that a good thing? Well, if we type that we want to query, and this is GraphQL query language, curly brackets, we then get a list of all the objects that we can query on. It gives you a kind of IntelliSense functionality, which I think is absolutely wonderful. So we're going to look for launches, plural. Okay, now this is GraphQL query language. It looks very similar to JSON, but there are no commas. That's probably the simplest way of putting it. That's probably a bit basic, to be honest with you, but that's the way I like to think about it. It looks a lot like JSON, not JSON. So what we're saying is we're querying, we want to pull back our launches object, and then if we actually hover over here, another thing with loading the schema is that we can actually see that query launches brings back an array of launch objects, and that's denoted by these square brackets, which is quite a common syntax for an array. It's in particular JSON as well, arrays are denoted by square brackets. If we click on this, it actually gives you all the attributes, or fields more correctly in GraphQL language, all the fields on the launch object. Okay, so I'm going to say I want the launch ID, and I want the launch year, and I want the launch site. There we go. Kill that. And then I think this is a nested object probably, so that's why it's complaining. So we need to go in and specify more details. So again, for launch site, we hover over that. It's a launch site object, and you can see you get site ID, site name, blah, blah, blah. So I just want the site name. Now, I've never really, let's theoretically say, I've never really used this API before, but already I'm able to query it and interrogate it using this kind of schema-based IntelliSense functionality. It's really great. It's really usable, I think, and actually very easy to use. So let's send that over. And that's going to give us a kind of all our launches in the same way that you've got all our launches here, but you can see here we've got all this data that maybe we don't need. And with GraphQL, the nice thing is you only pull back the data that you need. It's the same data, but just reduced. Okay, so quite nice. I like that. That's good. And then just to prove the point, let's just do one for rockets. So new request, get all rockets. And again, post request, GraphQL for the body, create. And as with this, it's the same URL. It's not a different URL, it's the same URL. Pop that in, refresh schema, and we'll write a query, curly bracket, and we will get our list of objects that we can query, and I want rockets this time. So pick plural, curly brackets, and then the IntelliSense can be good, but can also be a bit of a curse because it means you sometimes select the first attribute that you may not want. So let's just take a look at our rockets. So yeah, I want to see whether this rocket's active. I would like the name, if we have the name somewhere, I presume we do, name, and type. Okay, so active, name, and type. Fantastic, and that's all I want. Okay, I don't want anything else. And let's send that over. There we go. So we get, all these rockets. This particular one, Falcon 1, is not active. It's a rocket. Its name's Falcon 1. There you go. So we've only got 4 rockets there. And if we come back over here, again, we got all our rocket data, but we've got every attribute back with it. All right. So again, just a useful exercise, just an exercising of these APIs. So we're effectively going to take these requests and we're going to bundle them into code using our Blazor client Fantastic. But what we're going to do next is we're actually going to look at the payloads, the JSON payloads that we've got returned, and we're going to build some objects, or some classes more correct. We're going to build some classes, C# classes from these JSON objects so that we can model them within our Blazor app. And we're going to do that next.
All right, so let's just minimize Insomnia for a minute and let's come back into our project. And what we're going to do is, we're going to actually make some API calls now, you'll be pleased to hear. But to begin with, all we're going to do is we're going to adapt this existing component that came with the scaffolded application, the fetchData.Razor component. We're going to adapt it and bend it to our will, change it to do what we need it to do. But before we do that, let's just take a quick review of what it's actually doing, and then we'll look at what we need to change on it in order to make our API call. Now, we're going to be working with a REST API to begin with, and we're going to pick, I think, the launches endpoint to work with launch data. Okay, so before we do that, let's just go through this existing component and take a look at how it's working. So as usual, page directive at the top, you're familiar with that now. And then this inject statement. And what this is doing, it's making available to us, or to this component, an instance of HTTP client. And you can see there's the class there, the HTTP client class. And we get this instance of it that we can use through this component. So how does that inject work? Well, in order for that to work, let's come back to our program class. And you'll remember in our main method, where everything kind of kicks off, we have this line here where we are registering in our dependency injection container, in our services collection, we're registering HTTP client. And that just means that we can then use HTTP client throughout the rest of our application using that inject statement syntax. That's it, it's that simple. So that's all we really need to know about dependency injection as far as this video is concerned. Not that complex actually. Fantastic. So let's come back to our component and keep going. So we then have some simple HTML that just displays some headings on the screen in a paragraph. And we come down to this if statement here, and we look at this forecasts object or whatever it happens to be to see whether it's null or not. If it is null, then we display loading on the screen. Now, before we come down, if it's not null, we come down to this next section, which I'll come back to in a second, but I just want to jump down to understand what is forecasts. Well, as you can see here, it's an array, okay? An array of this class type here. So here's the class definition, weather forecast, a fairly simple class with date, temperature in degrees C, a summary, and then a little converter to temperature in Fahrenheit. That's it. And so all forecasts is an array of these class types. So when the page then loads on initialized async, we make use of our HTTP client. We use this get from JSON async method. It expects a type, and the type that we're specifying is an array of this class type here. And the data, the location of the data that we're expecting, the JSON we're expecting, is at this location here, and it's just a file. So you'll remember, maybe, hopefully, in www, in our static files, we have a weather JSON file, which is just a bunch of JSON data. It's not that complex. So this is analogous. This JSON file is analogous to our API JSON payload. It's almost the same thing. So if we come back to fetchData.Razor, instead of having a file location, we will have, any guesses? An API endpoint. So that's basically the pattern. And then if we come back up here, then obviously, if forecast isn't null, we've got the data effectively. We have a HTML table, and then we just iterate round our forecasts collection, and we pull out each of the object components. So this is basically showing you the data that's been deserialized from just the JSON file, and it's actually in a workable object structure now. And we're going to follow exactly the same pattern. Cool. So what do we need to do then to get this working with our API endpoint? Well, the first thing I think we should do is define the class that we're going to use to deserialize our JSON data, because we can't use weather forecast because our data is completely different. It's launch data. So that's the first thing we're going to do. All right, so what we want to do now is create a class, a C# class, that is going to contain our launch data, or contain an instance of a launch object that we get from our launch API. So let's come over to an application and let's right click and do new folder. And I'm going to call the folder DTO or DTOs. Now what's a DTO? A DTO is a data transfer object, and it's what we're going to write next. And the whole point of data transfer objects is that they're used to
bring data into your application and also send data out of your application. And they kind of help form part of this external boundary of your own application. And then usually what you do with a DTO is you'll map it to your internal data models. And the reason you do that is that if the external contract changes, someone changes the API and you need to change the DTO, that's fine. All you need to do is change the DTO and then the mapping to your internal stuff. And the rest of your internal stuff can remain unchanged. So it's just a separation of concerns again that I've kept talking about. So that's all a DTO is. They're usually fairly simple objects, and the one we're going to build is no exception. But the road to building it is a little bit complicated if you've not done it before. So it might take a little bit of time. So bear with me. Anyway, on the folder, we're going to create a DTO class. So right click and new file. And we're going to call it launch DTO.cs to represent our launch object. And then namespace as usual. And it's Blazor API client and then DTOs. And that's it. I'm not going to actually start writing the code just yet. In fact, I'm not going to write the code. I'm going to get a tool to help us generate the code. Now, usually I don't like code generation tools, but in this instance, I think they are quite useful because they do a lot of fairly repetitive stuff, and they can also help with understanding some fairly complex JSON objects. So anyway, you'll see what I mean when we come on to doing that. So to kick us off on that journey of creating our DTO, what I want to do is come back over to Insomnia and take a look at the payload that we got back from the get all launches API call. And you'll probably recall that we got a large JSON payload, which is an array of multiple launch objects. Now, all I want to do as a first step is isolate a single JSON object from this payload, and then we'll take the next step. But that's the first step I want to do. So in order to do that, I'm going to select all of this, copy it, and I'm going to copy it into my favorite online JSON editor, which happens to be JSON Editor Online. There are lots of other tools available, but I just like this one, mainly through force of habit. So select the example payload and delete it, and then paste in our payload from our API call. Now, there's two views in this particular editor, the code view, which you're seeing here, and a tree view. And you can select code and tree view in the same panel, but I'm going to copy this code over to the second window, and it shows you it in tree view by default. So what you can see here is we have an array of 111 launch objects, and each one of the 111 objects, as you can see here, has 19 attributes. So if we expand this first one, you can then start to look at the 19 attributes that it has. And furthermore, you can actually see that some of these attributes are indeed classes themselves. They hold objects themselves, should I say. So straight away, this object is looking quite complex, and I don't really want to model this in its entirety. I'm going to keep it a bit simpler, but we're getting ahead of ourselves. What I want to do first is isolate a single object. So back over in this window, you can see here that you get these little arrows, and line 2, you can click it up and down, represents one object. Line 100, the same, so on and so forth. Now what I want to do is just select this one object. So the opening and closing curly bracket, and that is all. Don't want to select the comma or the opening square bracket. So right click, copy, and then I'm going to clear this out. So right click, Control and A, and delete. And then I'm going to paste in the single JSON object. And if I copy this over to this window, you can see, yep, that looks correct. We've got a single object with 19 attributes. Now what I was saying is, I don't want to model all of these 19 attributes in the class that we're going to build. You can do, and again, these automation tools that build the models for you, this is where they really come in useful, because it's very laborious to build this yourself. But we're going to keep it even simpler than that. So I'm just going to pick a few attributes, top level attributes, that I want to pull back. So I'm going to take this one out, the details out, because it's too much text. I'll keep the first 3 of these. These look kind of reasonable. And then I think there was a mission name that I saw. Yeah, mission name, this one here. I'll keep that one as well. Everything else I'm going to get rid of. So let me just select all this. And again, this is a slightly sort of manual curation process, and it's entirely up to you if you wanted to do this or not. You could just model the entire object, but I want to keep it simple for this video. So this is a very, Actually, if you click here, it should just reformat it, and it will show you if there's any. If you take this colon out, it'll give you an error. So it's pretty good. So that's great. Let's copy it over here. So we have an object with 5. Actually, I don't want this one. Let's take that out. Just want 4. There we go. So we got ID is tentative, launch date local, and mission name. That's all we're going to model. Now you might go, well, what happens when you pull all that data back from the API? Where does the rest of that data go? Well, it just won't get mapped to the object that we're going to create. That's all. We'll just fall away. Cool. So we've now got our simplified view of our individual launch object or launch JSON object. And what we want to do now is generate some C# code from this. So copy this and come over to the second tool. And this is just called QuickType. So in here, in this window, you can paste in your code and it will go away and it will generate an actual code class for you of the language of your choosing. Now, just before we do that, I'm just going to come up here and give it a name. And the name I'm going to give it is exactly the same name that we gave our class in our project, LaunchDTO. And I'm going to select C# as the language that we want to generate. And you can see it's gone away and it's generated something way too complicated, way over the top that we don't really need. Now, in fairness to it, you can kind of configure what you need. And all I want, rather than complete, which is way over the top, I just want attributes only. That looks a lot better. Now, before we go on, I'm going to copy this. I'm just going to copy it into our project. But before we do, I just want to draw your attention to a couple of these using statements up here. This one in particular, Newtonsoft.json. So what is that? Well, many years ago, in a land far away, many years ago, Microsoft didn't really have particularly good support for JSON. In fact, some may say they had no support for JSON. So Newtonsoft came along and they wrote a library. They wrote a namespace, Newtonsoft JSON, that does all sorts of serialization and deserialization. It's a fantastic framework. But what we have now, Microsoft have subsequently kind of caught up and they've brought out their own framework. If I can find it over here, I've got the article here. Yes, it's system.text.json. So we're in this kind of weird spot now where I think probably most people are probably still using Newtonsoft JSON. You'll see it everywhere, but people are now starting to move to the Microsoft framework. And by and large, for what I want to do, it's like for like. But if you're doing some more complicated stuff, Newtonsoft, I think, is still way ahead. In this article by Microsoft on how you can migrate from one to another, you can start to see that there's a lot of stuff that's not supported in the Microsoft framework and with a workaround, and some stuff that's just not supported at all. But for our purposes, we're going to go with the Microsoft framework. Now, this tool is using the Newtonsoft JSON framework. Not a big issue, and I just wanted to call that out because I'll go through what the differences are. But for now, I'm just going to copy the class. I'm going to copy it over to our code. And then I'm going to go through it again in a bit more detail, and you'll see a couple of little call-outs that I've got. So straight away, we're getting a lot of errors suggesting that we don't have the right namespaces in. Now, let's go through these things here, these JSON properties. What are they? Well, if you look at what it's sort of specifying, it's saying JSON property, and then it's got a string in brackets. This one's ID, mapped to our actual property called ID. This one is underscore tentative, mapped to our C# property is tentative. So what it's really doing is saying, in terms of .NET naming standards, this is the right way to name a property. We wouldn't want to name a property that. You could, technically, but it would be going against all sorts of naming standards. So what this is really doing is saying, if I bring it up, in the original JSON payload, we have an attribute called is_tentative, and we're basically, this JSON property thing is saying is we're mapping that, the JSON attribute name, we're mapping it to the C# property name. That's all that is doing, okay? And we're doing it 4 times, one for each property. So that's cool. So the reason I was talking about Newtonsoft JSON is this is a Newtonsoft attribute. The Microsoft attribute is not named the JSON property, it's called JSON property name. So we have to rename these JSON property name. So I'll just go through all of these. Probably should have done a find replace, but I've started, so I'll finish. And it's still complaining, and that is because we do need to bring in the namespace. So control period to bring in system.text.json serialization, and that should all resolve. Fantastic. And we'll just bring in date time using system. Now we have one other thing here that's a little bit of an anomaly, and it's a little bit strange. Now, if you take a look at, let's take a look at this one here, mission name. It's saying it's a public property, fine, it's a string called mission name. And if we come back over here and we look at mission name, yep, mission name, yeah, we've named it differently, and the value of mission name is a string. Great, it's done a good job there. And the same for is tentative, it's a Boolean, cool, it's identified that. If you come back over, yep, it's identified that as a bool, cool. But if you take a look at ID, ID is actually a string as well. It's not a numeric type, it's a string. Now that's quite strange. I mean, typically IDs are usually numerics, but the author of this API has decided that it's not, that it's a string. Well, that's cool. But what this framework has decided to do is it's looked at that and it's tried to, I guess, apply some intelligence and say, no, 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 that's not a string, that is a long. And the reason for this here is what it's trying to do is convert the source JSON, which is a string, and convert it to a long, right? That's what this is. And if you remember, if we go back to the code here, if we mark this as complete down here, there's actually I think it's a class that does this conversion. I think it's down here somewhere. There we go. So it's tried to be way, way, way too clever for my liking, and I don't need that. Now, from my perspective, ID is a string. Although that's quite weird, it is a string. So I'm going to override the algorithm, and I'm going to specify this as a string, not as a long. And I'm taking this out. We don't need this now because we're not converting from a string to a string, so we can get rid of that. And that is now what our DTO should look like. And I think that should now compile. So a lot of steps there. We could have written this ourselves, but I think, especially when you have a large class that you want to kind of convert to a C# object or some other language, those tools are good, but with the caveat that you check what they've done, because they can do some weird stuff as well. All right, so the next thing we want to do is update our fetch data razor component to basically pull back launch data using an API. And as part of that, we're going to make use of our new launch DTO object or launch DTO class. So as part of that, we can get rid of this weather forecast class because we're not going to be using that anymore. So we can get rid of that, save that off. And we're just going to kind of retrofit this existing component to replace weather with SpaceX launches effectively. So let's start from the top. And I'm just going to replace weather forecast with SpaceX launches. And I'll just change this as well to something like, I don't know, this is the launch data for the REST API or something. This is launch data pullback via REST API. That's good enough. All right, great. And yeah, so we're making use of forecasts and stuff, the forecast array of weather forecasts. So we definitely don't want that. So weather forecast is gone anyway. So let's get rid of that. And we'll replace it with launch DTO. I'll just make sure that's what that was called, wasn't it? Yeah, launch DTO. That's cool. Just copy and make sure it's the same thing. Looks correct. Yeah, that's good enough. And I'll call this launches rather than forecast. And what I'm going to do is I'm going to copy this and do a find replace. So we want to replace forecast, so Control H. So we want to find forecast. And I want to replace it with launches. So let's replace all of them. Great. And down here, rather than forecast, we will have singular launch. And this will now error out. So let me do the same thing here. Copy this, forecast, and replace with launch. There we go. Much better. Now, obviously, these attributes are completely wrong, so I'm just going to take these out, because we don't have things like temperature. At least I don't remember us having things like temperature on our launch, although maybe it's conceivable that they would. And we'll replace those with our DTO attributes. But first of all, this is kind of complaining that we don't have the relevant namespace. Let's see if we can bring that in. So yeah, using DTOs. Let's bring that in, and that should appear at the top here, using DTOs. So that namespace is brought in. And we've got some issues with this, so let's take this out and replace it with launch DTO. So this bears spending a little time on. This is basically our HTTP client. We're waiting on it. We're putting the result into launches. That all looks good. This is a get method. So we're going to use a get request, and we're going to actually retrieve JSON in all in one shot. It's quite a nice method. So get from JSON async. And what are we going to get? We're going to get an array of launch DTOs. Now, the only other thing is this. At the moment, we are retrieving data from weather.json, which is in here, down here. That's our file that we're using here, but we don't want that. We actually want to replace this with our API endpoint. So let's just take that out and come back over to Insomnia, and we'll paste in our endpoint. So let's make this a bit bigger. This is what we want here. I'm going to paste that in instead. Put that in here. All right, so we're just going to go to our REST API, REST API, and we're going to pull back launches. We'll get the JSON asynchronously, and we'll put them into an array of launch DTOs that will go into this field here, and we'll then iterate around. Now, these now should basically resolve. So I think the first thing we want is the ID. Great. Next thing we want is tentative. Next thing we want is launch date local. And then finally we want the mission name. I'm just realizing we probably want to update our headers as well, because this will make absolutely no sense now. Get rid of that for the moment. And so ID, tentative, and I'll do brackets yes, no. And this next one is launch date local. I'm just going to call it launch date. Put a space in, and then finally mission name. Cool. So let's just reiterate what we did. We removed our weather class because we're now making use of our launch DTO. We just changed some markup up here, and we just renamed some of our stuff here. We didn't need to rename it, but I think it makes more sense that we did. And yes, we basically have an array of launch DTOs, but this really down here, and again, we didn't really have to change too much. We just changed the type that's being returned. And the only other thing we really changed was the endpoint. That's it, it's that simple. So that should all work now. So if I do Control S and do a .NET run, to run it up, we should now, by clicking on our fetch data button, we should be calling our REST API and pulling that data back. So let's pull this up and go over to localhost. That wasn't even anywhere close, was it? Host 5000. And if we click on fetch data, holding our breath, we have success. A bit of a slow response, but nonetheless, it's pulled back all our launch data with the ID, whether it's tentative or not, launch date, and mission name. And I've spelt mission name wrong, not spelt it wrong, I've put the wrong capitalization in. So I'm going to change that, although that's a very small error. So you might be going, well, that's great. Are we at the end of the video? We've pulled back data using Blazor, using a REST API. And yeah, I mean, if you're happy with that, that's cool. But I think there's a lot of other things we can do here to make this much, much better. We can optimize this in a number of different ways. So we'll move on and we'll do that next. Right, so the optimizations I'm talking about really are around splitting out our concerns. And we've already kind of started to do that. So if we come back over to our project, what I mean by that is we've already moved our launch DTO into a separate part of our application. It's not in this component code here. So we have our fetch data razor component. We don't have that class in here. We're bringing it in using a using statement, which I think is cleaner. And as our application grows, we might have 5, 10, 20 DTOs. So rather than having them mixed in your components, in fact, 2 components might require the use of the same DTO. It definitely makes sense to split it out and have them in a central location rather than having them stitched into your components. So definitely makes sense, especially for shared stuff like DTOs. And as we move on, we're actually going to make use of something I'm calling data services, which again, it's a similar concept. We're going to reuse shared components really. So our DTOs could be shared amongst components, as could other things. But for now, we're not quite there yet. But what I want to do is move this code out into a separate file so that all we're left with in our Razor component is predominantly markup. Okay, so just all this stuff here, predominantly user interface type stuff. There is a little bit of code in here, but for the most part, we're going to keep our .razor files as just user interface stuff. So it's quite straightforward. We come over to our pages folder and right click and do new file, and we call it fetch data. But give it a different extension. We give it a CS extension because it's just a C# class. And so you can see we've got a fetchdata.razor file and our fetchdata.cs file. And they are basically 2 sides of the same coin. So I'm going to declare or define our fetchdata.cs as a partial class. So at compile time, these 2 things actually come together and they are the one thing. So namespace first. Blazor API client pages. And then it's just a public partial class called fetch data. Okay. And all I'm then going to do is come over here and I'm just cutting out, selecting this stuff and doing an X to cut it, and I'm going to drop it in here. I'll do an Alt, Shift and F to format. And let me just come back here and just delete that, and I'm going to save that file. Fantastic. And then come over here and I'm just going to bring in the relevant namespaces for each of these things, so we don't get these red squiggly lines. All right, fantastic. So once that's all done, that should now work, to be honest with you. And you can see here that we're referencing this launches, array of, what do we call them? Launch DTO. So we've got an array of launch DTOs here, and it's quite happy because it knows that it can find it in here in this part of the class. The one thing I don't like though, and we'll fix it up in a second, but I just want to make sure this works, is this inject statement in this Razor file. I don't feel it should sit in here. I feel it should sit over here. But we'll deal with that in a second. We can take this out because it's not needed in this file, and we can save that off. So let's run it up, and it all should still work fine. Indeed it does, working okay, that's good. So kill the server, take this down, and I said the only thing I want to do is take this out of here. I don't feel it should sit in there, so let's save that. And what will happen, straight away, we get an error over here. Why do we get an error? Because it doesn't know what this is now. This is not being declared anywhere or defined anywhere. So what we'll do is we'll declare it as a private property. And it's going to be a HTTP client. Now this is probably going to... that's okay. And we'll call it HTTP. Make that get and set. There we go. And it doesn't know what HTTP client is. We need to bring in that namespace, system.net HTTP. And that stops complaining, as does that. But this still won't work, actually. And if you can guess why, give yourself a gold star. But I'm going to run it and show you why it won't work just yet. So it's run up okay, it's compiled okay, but if we refresh it, we're going to get an error. So F12 to look at our developer tools, and you can see here we don't actually have a value for what HTTP is. It's not been instantiated or anything like that. So we've not quite finished here, and it's quite an easy thing to do. All we need to do, and bear in mind, if you come back to our program class, we did add a HTTP client to our services collection, but we haven't really injected it into our fetch data partial class just by declaring a private property. That's not good enough. So what we need to do is inject, decorate our property with this inject keyword. We need to bring in the namespace. And what we're saying is, okay, dependency injection container, inject a HTTP client instance into here, and that will then mean that this is not null, and this should now work. So let's just save that off, and we'll run it up again. Kill it, rerun it. And yeah, it's all running. So there's my Edge instance gone. Let's refresh. And that's looking much better. We're not getting the error, and there we go, the data's come back. So all's well and good now. So basically we've split out our code from our markup, and that's how we're going to move going forward. Now, what I don't like about this is the fact that we are hard coding our endpoints in code, which you should almost certainly not ever do. So just before we move on to the final phase of this, I want to add in an app settings JSON file where we're going to put in our endpoints as configuration rather than code. So we'll do that next. Okay, so to add an app settings JSON file to our project, it's actually very straightforward. So just minimize our pages folder and we add it into here, into our other static files in www root. Now, just a quick sidestep, this weather JSON, we no longer need it. So I'm just going to take it out. It's making no difference if we leave it there, but I just don't like having stuff that we don't need lying around. So let's take that out. And then to add an app settings JSON file, just right click the folder as usual, new file, and then app settings.json. Now that'll work, but because this is really running in our development environment, I want to make one specifically for development. Now you need to name it exactly like this because this is just one of the standard .NET configuration sources. So app settings, all lowercase, .development with a capital D, .json. If you want to just use app settings.json, that's fine as well. Both will work equally as good. Now, just a JSON file. I'm sure you've seen these before, and you just provide like a key. So I'm going to call this API base URL. And then into here, this is where I'm going to configure our base URL for our API. So if we come back over here and look at our APIs that we've got our GraphQL and REST APIs. So the base URL is really this bit here. Take out this bit here, api.spacex.land, and then the rest of it is specific to either REST or GraphQL, and in REST case, you're going to have multiple routes to rockets and launches and all that stuff. GraphQL, you just have GraphQL. So I'm just going to configure, to start with, the base URL, and I'm then going to just continue to kind of hard code the route component until I'm comfortable with how it's all going to work, and then I might add that into the configuration file as well. But the real point of this is really just to show you where you do it and how you do it, okay? So that's our base URL that is in config now, and we can swap that out via config without having to adapt our code. So let's save that, and then to use that or make use of that, the way I'm going to do it is come over to a program class, and this is where we set up our HTTP client using dependency injection. And you maybe didn't see, if I do Control B to close that down, one of the things that is passed in by default is this base address, and they're just providing this hosting environment base address, which I don't want to use. I now want to use our configured base address. So the way you do that is making use of the builder object dot configuration, and then using square brackets and some double quotes, you specify the configuration element that you want. So Control B just to open this back up, and it's this here. Okay, provide that in to here, like so, like so. All right, so we're just setting the base address for any time this HTTP client is used. Now you may or may not want that, but in this instance, that's what I do want, so that's cool. So it's our base address set via configuration. And then all that we need to do is come back over to fetch data CS, and over here, all we need to do is take out this here. We don't need to provide that, it's the base URL, and then all we need to provide is the subsequent routes to the endpoints that we want. Now you could move these into config as well if you want, and I might do that later, but for now I'm just going to keep the video moving and just use the base URL and still provide the route in code, but that's probably not what you want to do going forward. But I want to keep moving because that would then become a bit more complex and so on and so forth. So I just want to show you how you generally set up a configuration. So that should all work now. Again, we'll get exactly the same result as before. This time we're passing in our URI, defining it as a base URL, and yeah, making a request to our APIs before. So let's just refresh this. And holding my breath here, there we go, data comes back. So all good, and then we could obviously go in and change that config file to another base URI as we needed. So yeah, that's basically app settings JSON done. So before we move on to the final section, I just wanted to have a bit of a conversation around what we've just sort of talked about there, the HTTP client and something called HTTP Client Factory, because we're going to be making use of that for the rest of the video. So let's take a look at that now. Okay, so these are the last 2 slides of this video. You'll be devastated to hear, and I really just want to do a bit of recap on HTTP client and then talk a bit about something called HTTP Client Factory. But before I even do that, one thing I want to make really clear up front is that we are always going to be using HTTP client. HTTP Client Factory is really just another way of creating them. Okay, that's all. Fundamentally though, HTTP client is at the heart of everything we do. So what is it? It's the recommended class, Microsoft's recommended class for sending and receiving HTTP requests and responses. Now, this is really the crux of the conversation. It's intended just to be instantiated once within your app and used throughout your app. Okay, that's how it's supposed to be used, but often it's not used like that. And so people will often create multiple instances, and even when they think they are being shut down or destroyed correctly, they often aren't. And what that means is you end up with this, as you can see on the screen, this socket exhaustion problem. Sockets connections are being left open, even when you think you're tearing down your HTTP client instances correctly. That's not always happening. So just stick a pin in that for the moment. That's an issue with HTTP client, or can be. Another thing to note, and this is really just an FYI, as I've mentioned at the start, HTTP client is the recommended API, if you want to call it that you use to make requests. And that remains absolutely true and continues to remain true for this video as well. There are other lower level, if you want to call them that, lower level APIs or lower level classes you can make use of to make HTTP requests, such as HTTP web request, which I have used in previous videos, but you're not really supposed to use them. You're really supposed to use this higher order class or API HTTP client, and that is again Microsoft's recommendation, so that's what we are going to be going with as well. But there are alternatives that you probably shouldn't be using now. Okay, so moving on to HTTP Client Factory, yes, it's really was introduced fairly recently to address this improper use of HTTP client, where you're creating multiple instances and not necessarily tearing them down correctly. So that includes even creating a HTTP client within a using statement. You might expect that once that using statement executes, that the instance of HTTP client will be destroyed appropriately and have all the connections closed off. That doesn't always happen, leading to this problem. So again, yes, it was introduced basically to help manage the creation of HTTP clients. We're still using HTTP client, we're just using this factory to help manage their creation and the underlying connections. So yes, in short, it manages these underlying HTTP message handlers for you. You don't have to really worry about them. So we're going to pivot and use this now in our application. Fantastic. So what we're going to do moving forward, we're going to create a new component dedicated to launches. Although we've already kind of got that, we're going to create a new component to kind of follow this model, and we'll take it from there. So we'll create a new component, and then yes, we'll start introducing data services and stuff like that. But let's move on to our next component. All right, so we're going to come back over to our project and create our next component, which is going to be dedicated to launches. So it's going to be initially, it's going to look very, very similar to what we already have, but bear with me, it will become different as we move through the example. So back in our project, we're going to create a component, and as usual, as you've seen before, 2 pages, 1 Razor page, 1 C# partial class. So let's do that now. So I'm just going to call it launches Razor. So this is obviously the Razor file that's going to contain our markup predominantly.
And then I'm going to create another one for a partial class. Launches CS, there we go. And so within Launches CS, we'll just put in the namespace, Blazor API client, pages, and then it's just a public partial class called Launches. And we'll leave it there for the moment, but we'll come back in a second. And then over in our Razor component, we want to put in the page directive, which is really the route to this component. Launches. And just while I remember, I'm sure you already remember this, but the name of both of our files should be exactly the same, with the exception of the extension, obviously. And as per .NET naming conventions, the first letter of the class should be capitalized. The page directive route doesn't need to be capitalized though. And then I'm just going to create some very simple markup. So just a heading, and we'll just say space X launches. Okay. Now, I do also want the table of data that we had in our fetch data Razor component, and I'm actually just going to copy that in because it's be a bit laborious to watch me typing all of this, and you've already seen it and seen what it does. So let's just copy that over into Launches Razor. And there we go. Now we should probably get some errors because it won't know what launches is. Okay, it's not aware of what that is. So we're going to put that into our backend code. So we'll just declare it private. It's a launch DTO array called launches. There we go. So it's exactly the same actually as what we've already got in our previous component. So we'll just bring in that namespace and save that off. And that all looks good now. Now obviously it won't actually work. We'll just see this loading because we've not got the data from anywhere, but that's okay. We'll come back and we'll tidy that up. And then the only other thing I want to do is create a button for this new component on our menu. So back over in shared, in nav menu Razor, you'll remember we had our list items here. So the last one we did was a base64 component, which was our previous component that we wrote. So I'm just going to copy that and paste that in, and then I'm just going to update the href, which is really just the page reference, so launches, and the icon I'm going to use the eject the eject icon, which, you know, in old video recorders and even DVD players, it's like a little up arrow. I think that kind of looks a bit like a launch. Sort of, and we'll just give it a label, launches. Fantastic, and that should be us basically. And so that's the same pattern. If you're using this project layout, create your components, 2 files. You can maybe just create 1 file if you don't want to split it, but I recommend you do, and then coming into the nav menu and creating a button to it. So let's take a look and see if that looks okay. So .NET run. And it shouldn't do too much. We're getting a warning because basically this isn't being used anywhere, but that's okay. It will eventually, so we will tidy that up. So let's refresh. And we do, we've got launches now. And if you click on that, it's just going to stay on the loading because it's not doing anything really, but that's cool. So there's our new component for launches. Fantastic. So what we're going to do next now is talk about data services and what they are and how we use them. And we're also going to look at our client factory and how that gets used as well. So let's move on to that. Okay, so I'm just going to minimize this and come back into our project, close that down. So yeah, data services is what we're moving on to next. And what is a data service? Well, as the name would suggest, it's a service that allows us to retrieve data. And it really is an abstraction. Okay, so data might come from an API, data might come from a database, might come from anywhere. As a consumer of that data, do we really care where it comes from? I want launch data. Do I care that it comes from a database, or do I care that it comes from an API? Do I care that it comes from a REST API as opposed to a GraphQL API? Maybe I do, right? Maybe the answer is yes, I do care, but maybe I don't. Okay, all I'm interested in is the data. So what data services in this context attempt to do is really say to the consumer, the person who wants that data, here, this is the data we can give you, and I'll take care of the implementation of how we get that data. Now, in this case, we are both the consumer of that data and also the creator of the data service, but conceivably they could be very different parties. And so
As a consumer, yeah, I might not be that interested. So that's fundamentally what a data service is. And in this case, we're going to create a data service for SpaceX, and you might then have another data service for another business domain like NASA or the European Space Agency. I mean, you could create data services around technology possibly, but I probably wouldn't do that. So I think it makes more sense to have a data service for a given domain. So in our case, SpaceX. So let's get started with doing that. So in our project, right click, I'm going to create a folder to contain our data services. And then the first thing I'm going to do is create an interface. Now, I'll go over what an interface is once I've typed this out. So SpaceX data service.cs. So yes, an interface basically tells the consumer, the person who wants to get the data, these are the things that we can give you. That's it. It just specifies the what. It doesn't specify the how. It doesn't deal with implementation. It just deals with what we can do for you. And it really forms part of a contract. And the idea is that as a consumer, all I'm interested in really is the interface. What can you give me? And how you decide to give me that, don't care, as long as it's the right thing. So it'll become more obvious. If you've not worked with this pattern before, it will become more obvious as we move through the example. But let's just put the namespace in for the moment, and it's Blazor API client, and it's in data services. Fantastic. And then it's just a public interface called SpaceX data service. And all we list in our interface are the method signatures of the types of things that we can provide. So we're going to be making use of a lot of asynchronous commands. So in that respect, we need to return a task of what? A task of launches, launch DTOs, or an array of launch DTOs. Which should look quite similar. I can get my typing working correctly. And then what's the name of the method? Get all launches. We're not passing anything in. So no space, get all launches. Now, yeah, we're returning, this method is going to return, yeah, just an array of launch DTOs. And the reason we're using a task is because we're going to be using this asynchronous programming model. It's really returning a task that allows us to await the method to actually return. That's a little bit outside today's topic, but we don't really need to cover it too much here. So if you're following along, just basically go with the flow. I didn't want to do that. I want to bring in the namespace. Rather, it keeps our code a bit cleaner. And then we need to bring in the launch DTO as well. Okay, and that's it. Okay, so I'm going to come along and I want to use this data service, and I can look in it and go, okay, it's going to get me all the launch data. Don't care how they do it. That's what it's going to do. But somewhere along the line, we actually need to implement it, okay? And that's where the concrete class comes in. So if we go into data services, we're going to implement it. Now I'm going to create an implementation for REST first. And the idea is I'll create a REST implementation, we'll get that all up and running, and then we can then switch out for GraphQL. And it means that we can switch out without affecting the consumer of the interface. As far as that person's concerned, which is us as well, we don't need to change anything in the front, because as long as the concrete implementation is adherent to the interface, it doesn't matter. So it's a really nice pattern. So again, didn't make sense, bear with us, it should do. All right, so we're going to create a REST SpaceX data service. So this is our implementational detail. And it's a class, so put the namespace in first, namespace, Blazor API client, data services is now there, great. And it's a public class called REST SpaceX data service. Now, in order for us to say that we are implementing this interface, we use this colon syntax, and then we give the class the name of the interface that we are wanting to implement. Now we'll error straight away, because basically what this is saying is this class that we're now developing is supposed to implement the methods that we've listed in here, and it's not doing that yet. So what we can do, click in there, control and period, and click implement interface. Now it doesn't actually implement anything, it just puts in this kind of boilerplate placeholder code with an exception that will get thrown, but it's good enough for the compiler not to kind of give us some warnings or even errors at this point in time. It would error out if we ran it, obviously, it would throw an exception, but at this point in time, it's not. So what we need to do next really is fill out this implementational detail to use our REST API. Fantastic, so let's just save that off. Now, before we do that, I want to now park this for a second. Imagine in your mind that we have actually done lots of magical implementational detail, and that's actually connecting to a REST API and pulling it back. What we need to do is actually register this data service with our dependency injection container in our program class in a very similar way that we registered our HTTP client. And we're going to register it in such a way that we make use of the HTTP client factory. Now again, you might be going, I'm not quite following this. That's okay. Bear with me. But before we move on to that, what we do need to do is actually include another package in our project file, because to use HTTP client factory, we need to bring in this additional package. So let's do that first before we do anything else. So control and back quote, clear the screen, and I'm going to do a .NET add package. It's Microsoft extensions. HTTP, I think that's right. We'll find out if it's not. Yeah. Okay, cool. So it's added our new package reference in, and that will allow us to make use of HTTP client factory. That's good. So I'll clear the screen, and we'll get rid of this, and we can get rid of that. Now make sure that's saved. It's saved by default, but just make sure that has saved off. Now we want to come over to our program class, and we can actually do everything that we need to do to register our data service. Even though we've not implemented it, we can tell the dependency injection system all about it at this point in time, and then we'll finish off by actually implementing our REST service. So I'm just going to do a Control B to get rid of the directory window so we get a bit more room, and then under our existing registration for our old approach, we're going to now make use of HTTP client factory. So very similar actually, builder, services, so we're still adding to our services collection, but this time we're going to add a HTTP client. And this is really the HTTP client factory in action. We're using HTTP client factory now to create our data service, and then you'll actually see how we make use of a HTTP client from within that. But this is the magic that's happening at this point in time. And what we need to tell the factory is what interface and what concrete class are being used. So our interface is what did we call it? SpaceX data service, and the concrete implementation in this case is REST SpaceX data service. I think that's correct. Let me see. Here we go. Using data services. I think that should resolve both of them. Maybe this one was typed wrong. Let me just check what it was called. REST SpaceX data service. REST SpaceX data service. We did put it in the right namespace, so it should be right. So just copy this. There's maybe a typo here somewhere. I'll do a Control B to get rid of that. Yeah, I'm missing an I. So my rubbish typing again. Put that in, and that should be okay. Fantastic. Okay, and similarly to what we did up here, we can actually specify a base address, which I am going to do, because irrespective of whether we're using REST or whether we're using GraphQL, the base address will remain the same. So just to keep it a bit simple, I'm going to take a new line, and you do this via a Lambda expression. So I'm going to say SpaceX DS data service goes to SpaceX data service, and we should have base address there. There we go. Equals new URI, and then we just specify the base address, and I'm actually just going to copy the code that we have out here just to get our base address from config. You remember we did that in a previous section, and I'm just going to paste that in here. And I think URI requires, no, that's all good. I'm using it up there. So basically, let's just recap what we did there. So we're going to be using HTTP client factory to register our data service, and you'll see how HTTP client comes into play in a second, but we're using that to register with our dependency injection container our interface. So we're going to request our interface when when we come to using it, and we will get given a implementation using REST, which we've not yet built. And then down here, we're just using a Lambda expression to specify the base URL, which in this case is the base URL for our SpaceX APIs. Cool. So that should all build. I mean, it won't actually do anything really. Well, it will register what we've told it to register, but it won't run because we've still not implemented our concrete class. So we'll do that next. But I just want to do a .NET build just to make sure we're not introduced anything weird. I think we'll still get a couple of warnings. Yeah, the launch is in our components not being used, but that's okay. That's just a warning. Okay, that's fine. So next we're going to finish off the implementation of our REST data service and then plug it all together, and it should all work. So let's do that next. All right, so back over in our project, I'm just going to close down our terminal, and we're going to come back into our data service class, or REST data service class, bit of a mouthful. So what do we have left to do in here by way of implementation? Well, we need to get an instance of HTTP client passed in somehow, and then we just need to implement our getAllLaunches method. So where does HTTP client come from? Well, we're going to get it through something called constructor dependency injection. And so what that means is we'll write a constructor for this data service class. So when it gets instantiated, at that point, the dependency injection system will give us an instance of whatever we ask for. And in this case, we're going to ask for a HTTP client that's been created for us by our factory. So back over in our program class, this whole registration here is basically allowing us to get hold of a HTTP client created by the factory because we've used this add HTTP client method. All right, so maybe a little bit abstract if you've not used it before, but bear with me and it should become a bit more clear as we move through the example. So to create a constructor, type CTOR and then tab over into our parameters section, and we're going to request a HTTP client to get passed in. We'll call it HTTP client. So at the point when this class, our REST SpaceX data service class, gets called, constructor gets called, and we get an instance of HTTP client passed in. Now in order to use that, we need to assign it to a variable that we can use. So we're going to create a private variable, HTTP client, and we'll make it equal to whatever's been passed in. And this does not yet exist, so control period to create a private read-only field. And that will get created up there. And just make sure you brought in the namespace for HTTP client. If you don't have that, obviously bring that in and save that off. And now this here is a very common pattern that you'll see used time and time again in .NET applications. So that's us got a instance of HTTP client, theoretically, or in actuality. And so all we need to do now is use it within our getLaunches method. So if we come back over to our fetch data component, we're going to do something fairly similar. In fact, we're going to do something exactly the same, pretty much, as this here. So let's just copy that, in fact, and we'll bring it back over into REST SpaceX data service. And we're just going to return this. Okay, so we're going to await on our HTTP client. So we just need to change this to underscore HTTP client. And we need to, as this is an awaiting statement, we need to make sure that this is async. And that should hopefully resolve that error. And then launch DTOs, we have DTOs. What we're getting an error on is this extension method, get from JSON async. So we need to bring in another namespace using system.net HTTP JSON, and that will bring that in for us. And that should be good. Now the reason, again, it's exactly the same as what we already had. We already have our base URL configured at the point when we registered everything in dependency injection. We created that here. So all we need to pass over is the remainder of the path or the route to our endpoint. Fantastic. So that's our data service implementation completed. So really all we need to do now is use it from within our new component, our launches component. So we'll do that next. All right, so yeah, all we want to do now is in our launches component, our new launches component, we want to basically make use of our data service. And again, if we pop back to fetch data, we're going to do something fairly similar to what you're seeing here. As opposed to injecting a HTTP client, we're going to be injecting our data service. And other than that, it's pretty much exactly the same. So let me just copy this protected override async on initialize method. I'm going to put that into our launches partial class as well. And we'll just close that off. And yeah, it's just saying we don't have any await operators on there. That's fair enough. So what we want to do, first of all, is rather than injecting a HTTP client, we're going to inject a data service. So back over here, we're going to use the inject parameter to inject a I space X data service component, and we're just going to call that, I don't know, space X data service, and we'll make it to get and set. Fantastic. Okay, so it's being injected in exactly the same way as our HTTP client had been injected. We're just injecting our data service. Now, because again, keep labouring this point, if you know about the dependency injection, my apologies, but for those of you who maybe don't, again, because we've registered here and we're saying if anybody asks for this interface, give them this concrete implementation. So back over here, we're asking for this, and we're going to get a REST space X data service injected. Fantastic. And then all it remains to do is we just need to set launches to something. So launches equals space X data service, get all launches, and then we will probably get an issue here because we have to await on this, and that will resolve that issue as well. So that really, to be honest with you, is it. Very similar pattern, but we're just using an abstracted data service and also using a client factory to get to our APIs. So I'm thinking that's good enough for us to run. So let's just get the command line up. Let's do a .NET build, and this warning should be disappeared now. They'll have disappeared now. Indeed it is. So we'll do a .NET run. And I'll just bring up our Blazor client, and let me just refresh it first. And so fetch data was already working, so let's just check that's still working. Should be. Great, and now if we click on launches, this should be making use of our new data service via a HTTP client factory. And indeed it does. So again, we're getting pretty much exactly the same thing back, but we've done it in a slightly different way using a data service and HTTP client factory. Fantastic. So what's really left to do? There's a couple of things I want to do. We want to implement GraphQL now. And the way we've architected this now is all we need to do is create a new GraphQL concrete implementation of our interface class and swap it out. And we should get exactly the same result, but using a slightly different technology. So it's really showing you the benefits of using this interface pattern. So we'll do that next. Okay, so we want to start working with GraphQL now, as opposed to REST, and it's slightly more complicated. Not much more, but it is a bit different, if nothing else. So coming back over to Insomnia, let's take a quick look at the differences between the two. Let's refresh our memory. So with REST, number one, it's a GET request, so it's just a URI, and there's no body or anything like that. It's just very simple. And then the payload is JSON, fine, and the payload is basically an array of objects. All right, so square bracket denoting an array, and it just launches straight into the number of objects we get back. And if we come back to our code, what we've done quite correctly is we have modeled one DTO, launch DTO, with a select few parameters, and then within our code, wherever, for example, here's our REST data service, we've said expect an array of those DTOs, and we've handled it that way. So we only have to model the launch object as a singular, and then in our code we specify it's an array. So that's all cool, that all works nicely. When we move over to GraphQL, there are a couple of notable differences. So the first one is that it's a POST request, not a GET request. So we're going to have to write our code slightly differently. what we've done so far has been geared towards GET requests. We're going to have to make it as a POST request, and we're going to have to add a query body to that request. Point number one. Point number two concerns our data, and this is what we're going to have to look at first. We're still getting an array of objects, and the fact that we've specified a reduced field set is irrelevant. It's still an array of objects, but we get these additional attributes here, data and launches, okay? So we're going to have to account for that in our modeling somewhere, okay? We can't just use what we've already got, which is just a singular launch object. We're going to have to extend our DTOs slightly. So we have to do that first. So that's really the two main things we need to do. And then we'll build our GraphQL data service implementation and just swap it out for the one that we had been using, which was our REST implementation. So let's go on and do that. Okay, so the first thing I actually want to do is just update our GraphQL query so that it's going to return a payload that matches our launch DTO. So if I come back over to our project, yes, here's our launch DTO that you should be quite familiar with. So I just want to return a payload that will get deserialized into this class. At the moment, we're bringing back some kind of random fields that we're not really going to do anything with. So let me just take these ones out and keep ID. And we want to return is tentative. We want to return mission name. And we want to return launch date local. I think that's right. So ID is tentative, mission name, and launch date local. That's the ones we've got here. Yeah, that's cool. All right, so let's just make sure that pulls back some data. And it does. So again, just to reiterate, using REST, we are getting an array of launch objects that have every field that's potentially available for a launch object. With GraphQL, we're just pulling back a subset, but it's effectively the same object. It's just this object here, but it's just got fewer fields, obviously, in this case. And we still have an array of them, and all we want to really do now is just model this data and launches attributes here. So as before, we're going to use some tools to generate the code for us, and then we'll double check it to make sure it's correct. So I'm just going to select this payload, copy it, and then I'm going to come over to our JSON online editor, get rid of this default payload and paste in our payload. And we want to kind of model this. So what I'm going to do is I'm going to keep this data object, I'm going to keep this launch array, and I'm going to keep our first launch object so our tool knows how to model it. And then from here onwards, I'm just going to, from here onwards, this comma here, I'm just going to get rid of all these 110, I think, wasn't it? 110 objects. Now, the code generation tool, even if we pasted all those objects in, it would still be able to generate code for us, but I'm just kind of doing this just so it's a bit more readable for us. And as you can see here, what we've got this data object, which then contains a launch object or launch array, launches array, and it just has one launch DTO effectively in there with 4 attributes. So we'll take this now and we'll copy it, and we'll copy it into our QuickType tool. So I'll get rid of the default payload and paste it in. And just over here, I've got language C# attributes only selected. Now, as before, it's generated a launch class for us, which we don't need. We already have that. That's our launch DTO, so we can safely ignore that. And all we really want are these 2 classes here. Now, the only other thing I'm going to do actually is just rename this kind of root class. It's currently called welcome. I'm going to call it GQL data instead. There we go. And what this is doing, let's work from the kind of ground up. What we're going to expect is a data class, and that data class is going to contain an array called launches. And in this instance, it's an array of launch objects, which is this object here. Now we'll just need to update this to launch DTO, as that's what we've called our launch object. And you'll remember the JSON property. We're going to have to update that to the Microsoft JSON library syntax, not the Newtonsoft syntax. And then working a bit further up the tree, we're going to have a root class. We'll just call it GQL data, and it's going to expect a property of data, which is this thing here. Okay, so it's a bit of a hierarchical tree structure of subclasses and so on and so forth. So it can get quite confusing if you're doing this yourself. So I find these tools are quite useful, at least initially, to help you understand how to structure things. So we're just going to copy these 2 classes. So right click copy, and then we'll come back over to our code, and I'm going to create a new DTO. new file, and I'm just going to call it gqldata.cs. Give it a namespace of Blazor API client, and it's in DTOs. And I'll paste that in. Now, I generally don't like having multiple classes within the one file. I'd usually like to split them out, but as you can see here, rules are meant to be broken. And because these are such small classes, I think it would be a bit over the top to create a class for GQL data and then a class for data itself. It would be a bit unreadable and a bit confusing. So I'm just keeping that in the one file, and we're keeping our launch DTO exactly as is. That's not changing at all. So the first thing we will change actually is this property here. Instead of an array of launches, it's an array of launch DTOs, which is basically an array of these. That's cool. And we'll change the JSON property to JSON property name to adhere to the Microsoft JSON serialization framework. But of course, we need to bring in the namespace, so control period, to bring in system text JSON serialization. And that's it. That's basically the DTO that we need to create. We don't need to change launch DTO, that remains the same. We just need GQL data with a couple of partial classes in there. And that's it. So all we need to then move on to is to create a data service for our GraphQL API and swap it out in our program class, and we should be ready to go. So let's do that next. So back over in our project, we want to create our GraphQL implementation of our interface. So on our data services folder, right click and new file, and we're going to call it GraphQL space X data service.cs, and then provide a namespace as usual. Blazor API client data services. And then, yes, this is an implementation class, so public class. We're going to give it the same name, so GraphQL space X data service. And like with our REST implementation, we are going to implement the same interface, I space X data service. Now, error out for the moment, but let's just leave that for a second. If we pop back over to the REST implementation, you'll see that, yes, we implemented this interface, exactly what we have to do with the GraphQL equivalent, but we also required the injection of a HTTP client using the constructor. So we're going to do exactly the same thing here. So if you remember, CTOR, constructor, tab, and then we'll tab into the parameters section, and you're requiring a HTTP client called HTTP client. And then in here we're going to assign it to a private field called _HTTP client. And this does not yet exist, so control period to generate a read-only field, which comes up here. And then we need to bring in the namespace for HTTP client. Fantastic, so I'll save that off, and all that's continuing to error out is the fact we've not actually implemented this interface yet, so let's resolve that to some degree by clicking in there and control period, implement the interface. And as before, we just get this kind of placeholder, which we need to obviously fill out with an implementation. So just popping back over to Insomnia and taking a look at our GraphQL API call, we're using a post request. I think I've mentioned this a few times now as opposed to a get request, and we need to pass over a query in the body. Looking back at our REST implementation, it was really quite simple. We made use of this get from JSON async method, which not only does the get request for us, but it also deserializes the JSON that we get back from the request. So it's pretty straightforward. The implementation we have to do here is a bit different, and we have to do a bit more heavy lifting. We don't have the luxury of using the get from JSON async method for obvious reasons. So no bad thing, it just gets us a bit more view of what's happening under the covers. So just a quick sidestep, if you're doing a lot of GraphQL stuff from a client perspective, you can adopt or make use of actual GraphQL clients. So in the .NET world, there's a few available. The one that springs to mind is the Strawberry Shake client by the same people that did the Hot Chocolate GraphQL API framework. And it takes away a lot of the heavy lifting required, the way I'm going to do it. So it's possibly something we'll look at later, but I want to do it this way because I actually want to do the heavy lifting and I want to use just a basic HTTP post request with a body. That's the way I want to do it in this case. But if you're doing this a lot, you might want to look at one of the clients that are available. So a library you'll make use of, and it again does a lot of the heavy lifting for you. We're not doing that here though. So yeah, we're relying on HTTP client and the features that it exposes to us. So the first thing I want to implement is our query itself, and the way I'm going to do that is just create an object that we will later serialize and pass that over to our post request. So var query object equals new, and it's going to contain two attributes. One called query, which is probably quite obvious. And I'm just going to make that equal to an empty string at the moment, but I'll come back and fix that. And the other one called variables, which will just make that equal to an empty object. Now you might be going, what are variables? Well, variables are quite straightforward, I think, but in the context of GraphQL, basically what they are. In this instance, we're not using them, of course, but with a lot of queries, you'll be passing in a query parameter, like an ID or a name or something, a string to, filter your results on. And the way you can do that in GraphQL is by actually providing it as a variable. And in Insomnia, you just create them down here as a kind of JSON object, and you then pass them in. We're not using them here today, but I'm just leaving that there as a placeholder should we choose to use them in the future. But what is important is the query that we want to use. So back over in Insomnia, I want to just basically use this query, but I want to put it all on one line. So I'm just going to do that manually. Not particularly nice to watch, but just make sure you don't, do what I did there and take out all the spaces, otherwise you're going to end up with errors. Now we will run this query once I've put it all in one line, just to make sure I've not done anything stupid. Cool, so we'll just copy that out and we'll paste it into our query string here. Fantastic. Let me just remove that white space, but everything else we'll leave as is. So yeah, basically we're creating this query object that we're now going to serialize. And where are we going to serialize it? Well, we need to use something called string content. If I just bring this over here, the string content class is something that we can pass over as part of our post request. And it allows you just to pass over a number of different things in a number of different ways. So well, probably makes more sense if we actually make use of it. So let's just do that first. Launch query equals new string content. And you can see there's a number of things that we can pass over here. So we're going to pass over our serialized object, which is basically the string content, the encoding, and then basically the media type. And in this case, we're going to expect application JSON as the media type. So let's take a new line and do each one of these three parameters on a line. So JSON serializer. We'll have to bring in that namespace, which should become quite familiar to you now. So using system text JSON. And just make sure that's resolving. So serialize. What do we want to serialize? We want to serialize our query object. Make sure I put in the T there. And then the encoding. So encoding, and I think I need to bring in a namespace for this as well, is just going to be UTF-8. Yep, so let me just capitalize that and bring in system text. And then the final thing we're going to specify is the media type, and that's just going to be application JSON. And we just need to put a semicolon there, and I might bring this up onto this line, and that looks a little bit neater. The next thing we need to do is actually make the post request. So the way we're going to do that is by accessing our HTTP client, and we're going to make a synchronous post, so post async. And what we're going to pass into that is the request URI, and all we need to pass over is GraphQL, because we already have our base URI, which is the base. If you actually come back over to Insomnia, you'll remember this is our base URI, which we have stored already. So all we need to pass over in this case is GraphQL. In the same way that over here we had to pass in REST launches. In here we just need to specify GraphQL. And then finally, well not finally, but then we need to pass over the content, which is this content string we've just created up here. So we specify launch query in here. So that's just making a post async request, but we need to put that into something. And the first thing we need to do is await it, obviously, because it's asynchronous. And we need to put that into a variable I'm just going to call response. And make sure we put space there. So hopefully that makes some sense. Now it's erroring out. The reason it's erroring out is because it's saying we're not in a asynchronous method. So we need to put that up here. And that should resolve. So again, I'll just go over that again. We're making a use of our HTTP client. We're using post async. And into that we pass over the URI, which is just the portion that is on top of the base URL. And we're passing over our content, which is this launch query here, which contains our query object. And then we're just going to await on that and put the response into, well, this variable called response. So you'll see this is much more complex than using the get from JSON async command. We're almost getting there though. So the first thing we want to check on our response is if it was successful or not. Okay, so do we get a HTTP 200? Or a variant thereof to 10 or something if we were getting that return. So if the response is successful, fantastic, we're going to then do something. If it's not, we're just going to return null. Okay. Now obviously that's not particularly wonderful. We'd probably want to do something a bit more detailed if we were getting an error, but for the moment I'm just going to return null. We may return to that at another point in time, but I really just want to focus on if it's successful. So if it's successful, this is a kind of two-step process, so I'll do it kind of from the ground up. So the first thing I want to look at on the response is the content, and we basically want to read as a stream. Okay, so we've made the request, the post request, it's been successful, and we're now going to get the data coming back and read as a stream. So once we have that response, we then want to deserialize it. Now it's complaining here because I'm not using the await keyword, so let's just do that first. So we're going to wait on that. So once we have that, we then want to deserialize it. So again, we're going to use the JSON serializer. This time we are deserializing, as opposed to up here where we're serializing the object, we are deserializing. And we want to use an asynchronous operation. And what are we deserializing to? We're going to deserialize to GQL data. Or GQL data DTO, which is over here, if you remember. GQL data, because we're getting a response in this format here, as I'm sure you remember. Let's await on this too. This is complaining for some reason. I think it's really, so basically we are deserializing to this, and what we're expecting as the input, we are basically just expecting this. So this is where we're going to take this, which is our stream, and we're going to deserialize to this. So I might just take a new line if it will allow me to do that. That looks a bit more readable. I might just tabulate that in, and we'll close that off with a semicolon. And we want to put that into something. I'm going to put that into a variable. I'm just going to call it GQL data. All right, so let's go through that again. So if we get a successful response, that's just the response code, HTTP 200 for example. We want to read the response, which is basically our serialized JSON as a stream. And we then want to deserialize that using the JSON serializer, and we want to deserialize it to a GQL data DTO, which is this here. Now that contains, of course, our launch DTO array, but we don't want to pass back the GQL data DTO as is, because we're expecting to pass back an array of launch DTOs. So what we do, what we return back is we access the GQL data object we've created, and then we navigate through data and then launches, which is basically an array of DTOs, as you can see there. And we'll just put a semicolon and save that off. Now that is basically our GraphQL implementation, so it's a lot more complicated than what we had to do with our REST implementation, but nonetheless, it should work. And all we really need to do to test it now is to come over to our program class, and we just need to simply swap this out for our GraphQL implementation. Don't think that, okay. So GraphQL SpaceX data service, and that's it. It should work. Fingers crossed. So we come back to our terminal, we'll do a .NET build. No errors, that looks good, and we'll do a .NET run to run it up. And we'll come back over to our Edge instance, localhost 5000. And if you click on launches, we're now using our GraphQL implementation, not our REST implementation. And query is successful using GraphQL. Fantastic. So basically, what we've just done there is we have created a GraphQL implementation of our existing interface, and all we needed to do in the program class was swap it out from the REST API that we've been using. And if we just come back over, let me just kill this and quickly go back through what we've done just to refresh. We created a query object which contained our query as a string, and we've put a placeholder if we wanted to include variables at some point in the future. We then made use of this string content class and we passed in our serialized object. We told it it was using UTF-8 encoding, and then we passed over the media type, which in this case is application JSON. And then we made use of our HTTP client, specifically the post-async method. We told it that on top of our base URI, it was GraphQL that we wanted to use, the GraphQL route, and we passed over our string content, and we awaited on that, and we put that into this response object here. We checked to see if it was successful, and that's just the success code. Assuming it is, we then read the response as a stream, and we then deserialize that stream and put it into a GQL data DTO and pass that into this object here. And then we navigated through that object to get to the launches array, which is what we're expecting to pass back as part of this method here, so it's adherent to our interface. And so with that, we not only reached the end of this section, but we reached the end of this entire video. So another long video, about 3 hours long, a bit longer than I had intended, but to cover everything that I wanted to, well, it's just ended up being this long. So I hope if you followed along, you enjoyed it and you learned something and you've ended up with something that's working, hopefully. In terms of next steps, I think for me, I would like to maybe use some different APIs that would allow us to add data, you know, create data, delete data, update it, that kind of stuff. I think that's possibly what I might do next. And then the other thing I would possibly do as a next step or a next video is focus in a little bit more on the HTTP client class and look at the ways that you can use that in more detail. So things like authentication, the types of headers you really should be adding to it when you're making requests and stuff like that, which we kind of didn't touch on too fully in this video. And of course, there's some things with what we've done already that you could definitely tighten up, such as error handling, and also possibly revisiting what we did with the configuration in app settings development JSON. We just added the base URL, so there's possibly some stuff you could do around there. Anyway, that's it for this video. Thank you again for watching. If you haven't done so already, maybe think about subscribing to the channel, and if you liked the video, please give it a like. Other than that, thank you again for watching, and for my very loyal Patreon supporters, big thank you to you as well, and your names are coming up next. But until I make my next video, stay safe, and I'll see you very soon.